Good morning, sir.
Good morning, madam. Can you hear me?
Yes, sir. Sir, am I audible? Sir, is my voice audible to you? My voice.
Yeah, yes. Please go ahead.
A very good morning, sir. So I'll be introducing starting the sessions. So a very good morning to all the participants of this AICTE sponsored 1 week online short-term training program on water quality complication, restoration and environmental conservation of existing water bodies, Module 2. We have with us today Dr. M. Selva Balan, sir, who is a scientist E, Joint Director and Head of Hydraulic Instrumentation and Canal Automation Division, Central Water and Power Research Station, Ministry of Jal Shakti, Khadakwasla, Pune. He is a postgraduate and PhD in computer science and engineering with expertise in underwater imaging systems, automation related to physical hydraulic models, SCADA, GPS, dam instrumentation, canal control system, port and harbors, and GIS. He is a very significant researcher with numerous publications in the journals. I welcome you, sir, on behalf of the Civil Engineering Department of IPS Academy, Institute of Engineering and Sciences, Indore, and I thank you for being present here and share your views with us today. Thank you, sir.
Good morning, everyone. So here, I will just confirm whether all the participants are faculty or students. You have students too?
So mostly they are faculties only.
Faculties. Okay, so I can talk in terms of some concepts than getting into
Yes,
the
sir.
details, right? Okay, thank you. Right, so I'll just share my screen. I think my screen sharing.
Yes, sir. It's activated, sir.
Correct. So you can see my screen now.
Yes, sir.
So, yeah, very bright good morning today to all the participants, faculty, the organizers, everyone. So, I am Dr. Selva Balan. I have been working in CWPRS for last 22 years. Being a CEO, I think most of you are all from civil and water resources background. I have
Yes.
been, yeah, right. So I am an electronic engineer. So don't think like we are talking in terms of two domains. I will, with the 2 years of experience, I hope I can able to connect with you and then make this session interesting. So being, the faculty, I'll be talking most of the technological advancement today, what is lacking in our country, which is very relevant in today's scenario for a water resources engineer to follow. So I hope based on my presentation, some of the faculty can able to pick up some idea from this and give your maybe your BTech, masters, as well as some topics on PhD level. Also, I have incorporated. So this is to give you an overview of what are the technological advancement available in today's scenario, which you can able to adapt and make the water resources field more useful, and hence you can able to manage the resources very precisely or more optimally. So with this background, let me say, like, my first slide, you can see there are certain electronic inputs and some sort of water resources related information. So I'm just trying to interlink between these two things. People might have heard about the concepts of artificial neural network, which has been there for 1950s onwards. It has been there for quite a long time, but it has been mostly handled by the electrical, electronic, and computer science guys. So people were orienting these concepts to a particular department instead of seeing it as an application related issue. So here what I am just trying to show is the model of our neuron system, which has been depicted in a pictorial view as a neuron structure. So what you are clearly seeing is there are some inputs coming in based on multiple inputs comes to the nodes, and then a decision making is happening, which is not at all seen or known to anybody, but based on these suggestions, an action is going to be taken out. Now, how accurate your action is going to be is based on the inputs what these neurons receive, and how strong is your neuron is designed with the concepts or the algorithms. So let us relate it to a civil engineering field. So here, this same thing, when you want to put it into a computer, you have to put it in a network like this. So I have just shown a typical example of a neural network with the 4 inputs, 1 output, with around 13 hidden layers. Each layer is about first layer 4, 55, 50. This is not a graphical output. This is the one which we have used to create an output of this reservoir to this. So that's what I have just not copied it is from anywhere, which is what been modeled by our engineers for a reservoir classification studies. So it makes sense here. So now what I mean to say is there are a lot of information is being put into the hidden layers, which is not known to it. So yeah, 10 input, or say for example here 4 input goes through hidden layers, going to give an output, and that is going to depend upon how this network is trained. That's what the technological advancement what you are required to know. And so this happens, this differs for every individual in a different way. I can able to relate this 4 to this in a way based on my experiences what I gained, which are stored in the hidden layers. Maybe your professor will be relating this to this in a different way based on those experiences what she or he had acquired. So the outputs are not depends only on the inputs, but on the experiences what you have. So you need to map this network with a good quality hidden layers. So what are the good quality and what are the good experiences? Let us see in the coming slides. Right. Now, why I am talking about all this technological advancement is with this type of networking architecture, without understanding the process domain, I can able to go and handle any process. This similar to this network, I have used it in 2016-17 to map a dam stability measurement. Similar type of network, without not being a geotechnical or a geological engineer expert, I could able to go very close to the output what they have calculated using an FEM model. So a takeaway point here is you don't go for 100% accurate solution, but without any field knowledge or much of the field knowledge, with a very the overall knowledge, still you can go to an accuracy of about 99%. It will never go to 100% accuracy. That's what is required in this type of prediction and management issues. So we recommend you go for such type of neural networks, which is other way called as a deep neural network. Deep neural network means you have a complex feedbacks and with multiple layers, more than 2-3. Right. So here what you are seeing is a reservoir bed profile. So this is the water depth about 15 meters. Then below that about 20 meters, I could able to map what is below the reservoir bottom. And I could able to see now as an electronic engineer with the technology, I could able to make some colors. Now, what is these colors represent is the field experts idea. So that's where the domain expertise is required. Now you will understand what is the field criteria, and you can say, sir, this is a rocky bed. This might be you can say something like a deposit of some material, clay, silt. So sort of this type of classifications based on some ground truthing, as well as by your experience or your theoretical concepts, you could able to classify or advise the machine what it is supposed to classify. Here it is just a color combinations, and here what you are seeing is a satellite image. From the image, what I am doing is I am just going and surveying one reservoir, a bathymetric survey. I'll explain you what it is, and by which I could able to get the profile of the reservoir. Now I am feeding the inputs which allowed me to get the profile as an input to the deep neural network, and I'll train the network for the absorption of satellite colors. Absorption of satellite colors in the sunlight reflection picked up by the satellite is being depicted as a bathymetric here. So once I train that, what happens is I could able to map the complete the scene of this imagery with the bathymetric profile. So one is measured, remaining all are predicted, and where we could able to show an accuracy of about 99%. So that is the specialty. You could able to create the contour maps inside a water body by making only one measurement at the top of it. Okay, so now here what you are seeing here is a typical bathymetry survey application. So here you have a reservoir top. A survey boat is being depicted here in a pictorial view. So it is picking its position from the global positioning satellites, so which is traditionally called as GPS, and the technical name is GNSS, Global Navigation Satellite System. We have many satellites, more than 100 satellites are crowded in the space, around 20,000 kilometers above. US and Russia's are the China, they have the major satellites for the to contribute to, and they give this signal free of cost for if you own a receiver on your boat. So by which what you get is your precise position of the boat inside a water body. So how precise it is, you can able to go up to a centimeter level accuracy with based on some reference settings and all, but that's not our topic of interest. So once your boat position is accurately pinpointed, the boat runs on a survey line, picks up the bed elevations. So from here it transmits the beam goes, touches the bottom and comes back. And by intelligently operating the beams with multiple frequencies, we could able to get the top profile as well as at a different beam, it could able to get the bottom profile also. So at any time, any point of time, you will get two different depths, which is being integrated over the whole reservoir area to get a volume of the reservoir. Now you'll get two volumes, but on two depths. So volume 1 and this is volume 2. The difference between these volumes are normally understood as a silt up portion. So the loss in capacity. Now here what you see in this photograph is these data shows the water below this layer to about 20 meters below the muddy portions. So that's further beyond this. This is not done with the acoustic signal. Here it is an acoustic sound signal. Here it is done with the current signal. This is called as a resistive profile. This is called as a acoustic profile. Now what we do by all these particular experiments is you create a area capacity curve by which, see now here I have created two curves. So one is from the original depth, another one from the present depth, and in between survey data also. So there are actually three. So you could able to map the elevation against the water spread as well as elevation against the volume, by which you could able to see at different elevations what is the capacity loss and the area loss. So this is a very, very important parameter for the water resources managers to operate the reservoir optimally and use the resources in a meaningful way. So the topic of water resources management comes in, is possible for a reservoir engineer, since I could able to give him the measurement very precisely done for a level from the bottom up to the FRL. So now the key element understood from this particular point is, in case if you could able to precisely measure, the position is precisely measured, I said in centimeters, and the depths are measured in again in terms of centimeter level accuracy. Hence the engineer could able to operate his reservoir in a precision. Right. So what is the key element from this particular discussion is the measurement accuracy. Unless otherwise you are not in a position to measure a process. It can be a water level, it can be a velocity, it can be a discharge, it can be a capacity, or any, for that matter, anything. You cannot measure it, then you cannot manage it. So the concept of I am going to manage it by this way, that way doesn't apply at all, unless otherwise you don't understand how much you have and how you have measured that quantity. And that should not be challengeable. Now India is facing a major challenge in water resources between interstates, inter-districts, and between countries and many other places. So many other events. So these disputes are big, could not be resolved so far because there is no proper approved measurement techniques being followed. So people follow the technology of his convenience. So multiple methods have been evolved or models have been evolved. They were all as the, as per the time and need. At that time, that was the technology, hence people used it. But now people use it for their convenience to complete a paper or make a project or to get into a dispute. So you need to understand what are the advancement in technologies and what are non-disputable technologies. So by understanding this, you get two important things. You will resolve dispute number one in terms of country as a country. In terms of a college, you will your paper or your result, what you produce will not be challenged by the reviewer, because the technology what you have adapted is an universally accepted, and the technology is well proven for anybody to the boundary conditions are universally accept common conditions. So I think that makes sense for this presentation to go further. Okay, let me I have already talked about many other things, but I'm just thankful to the coordinators and the organizing team for this great opportunity. So here, where the technological concept come in picture. So in every aspect of these water resources, every aspect includes, see, the catchment. I think everyone understand what is a catchment. The area which contributes to the reservoir water spread. So what is a reservoir? By construction of a structure, you store the water, and at the maximum water level, what is the area which is going to be occupied by the water body? So that's the water spread area. Now this is the catchment area, and the downstream you have canal systems, river systems, distribution system, many things. So I can, in a simple terms, I can put the complete water resources scenario in terms of this. So now I challenge at every point, are we in a position to measure how much rainfall we are going to get? Number one, that's a challenge. As a water resource engineer, it is no. Indian Meteorological Department can give you a prediction, but those predictions are based on some why those predictions cannot be very accurate, because the measurement on ground are very sparse. You have rain gauge stations. This is all jungle area. Catchment area is normally a dense forest. So where people going and installing sensor and maintaining it is challengeable. Hence, this is justified, but the point is you are not measuring it in a manner, as the area is you may have 100 reasons why it is not precise, but the fact is you are not measuring it in a very sparse interval. You are measuring it in a very in a wide distances, not at a very key points of interest. So now that is the challenge now. So what meteorological department trying to do it is, they do a mathematical model and they apply an evapotranspiration type of model, and they measure it in an atmospheric conditions itself with a high precision satellite, radar satellites. They could able to see the movement of wind and humidity, temperature, and many parameters. So that's going to be a very high-end computation, which we are not in a position to adapt so far into water resources. So in case if we have that type of computing technology and power, we could also do that. So let us assume we will accept the prediction by IMD. Then you need to validate whether those quantity predicted has actually contributed in this area. So you need to have a measurement. So at this stage, present day, we don't have a measurement system well established in the catchment area. So we have to go with the evapotranspiration type of model. It is evaporation and transpiration. How do we pick it up? This is all pick it up by satellites. And today's scenario, there are many satellites which are picking up, and many of the satellites are giving it free of cost and some on payment also. In case if we could able to access those data, your prediction accuracy at the catchment level is very nice, very perfect. And that from there you can able to do a runoff model, and then you can say this is the quantity of water I'm going to get in my reservoir. So this will make sense, instead of taking a gauge discharge readings from the field engineers, which is all measured once in a day or once in an hour, which create much error compared to a model one which you can able to always use it for this particular matter. And the another challenge what you face in the catchment area is, how do you transmit the data, because this area is a jungle, so where you don't have a communication medium available. So that is another challenge. But we have CWPRS have come out with multiple solutions with the radio communications, by which we could able to handle all this area where you don't have a mobile communication network, we could able to without satellite communication also we could able to get the data to a zone of convenience. Then in a reservoir onwards, probably we have a control. So normally the professors who take up projects normally consider their study area from a reservoir and down below. So for a reservoir, you have nicely the data available for the contour extraction, water level measurement, how much gate to be opened, what is the strength of the structure. And again, you can use an evapotranspiration model. Then you are interested in discharge, and in case of flood, you need to understand how much is incoming and how to operate the gate so that the flood is regulated. So all these things require a lot of knowledge about these measurement techniques. And to know how much water to be released so that the downstream is not flooded, you need to have a very good quality of a DEM available for this place. DEM is a digital elevation model of the downstream, which is being provided by again by satellites. Even Indian satellites like Bhuvan are providing it at a interval of about approximately about 30 meters resolution or so. But then still you can able to increase the resolution by a local survey done with the different satellites presently launched by the European satellite agencies. So with this intro now in today's scenario, all these processes are possible to be monitored and measured by what? By a concept called as an AIML, artificial intelligence and machine learning. So feeding the intelligence of a human, multiple humans, to a machine becomes an artificial intelligence of the machine, and teaching the machine and allow the machine to learn. That's important. So to make this process very very in control. And what all the data required? You require a lot of data regarding the catchment, reservoir, things like the cross section profile. You need the water land boundary, you need the water level, you need the discharge. So of which the water land boundary, the water level, and to an extent the depth of the reservoir, cross section profile also are possible to be extracted using the image processing technique itself. That is why this is the this topic makes sense. After 2015 onwards, this is possible and it makes sense. And today's scenario, we have space data available at 10 meters resolution with the repetitive rate of 7 days. However, you need to ensure is it a cloud-free data. So otherwise, in a normal lean period, you get a 7 days quality, very good data. During monsoon, probably this interval you need to be different. It may be different. So here what we have shown, all this we explained here is been shown here in a pictorial view. And once you apply the evapotranspiration and DEM, then you will know at what discharge, what area is going to be inundated. This is all very important. Then how do you people measuring the process by a most advanced acoustic Doppler profiler technique? A boat with an ultrasound sensor fixed at the bottom is pulled across. This will pick up the velocity components of the water at different locations wherever the boat is moving, and it gives you the bottom profile tracking. So at the end of the cross section pulling, what you get is the multiple velocity components plus the cross section profile, which will allow you to calculate the discharge at this particular cross section. Only disadvantage, it is a manual time consuming method where you need a person to go. So during flood it is not possible. So that's the only disadvantage, and you need this place is to be accessible for human to go and take the readings. And this is a non-contact measurement where a human interaction is not involved. However, a sensor is permanently fixed here. So this could be either a water level sensor or it could be a non-contact velocity sensor. So what it does, it picks up the surface velocity of the moving water body, and the computer or the hard drive inside the system is fed with the cross-section information once measured using the ADCP, and by which at every instant of velocity measurement, it calculates a discharge at the point. So it can be programmed, it can be remotely accessed. So all these advantages, only thing is you need to have a communication signal to be available. Either it could be a mobile communication or by any the satellite or whatever. You can have a dish antenna here, you can have a mobile thing here, or you can have a radio by which the data can be transmitted and brought back to your control room. Right. Now we have talked about so many things. Now why this is all relevant is this is the balance and the difference. So technically speaking, 4000 BCM has become 450 BCM. So remaining You can give thousands of reasons it has been lost, but it is lost. So how can we, so in case if you could able to use at least this 690, at least you are going to serve the huge population, and the coming years need such a additional food productivity. So you need to create more agriculture, and so you need to manage and the water resources precisely. To manage the resource, you need to measure it properly. Okay, so with the existing traditional way of handling things will not end up bridging this gap. So it is a kind request, or it is a mandate or a need of the day for every teacher, every technologist, every scientist to adapt a technology which uses space data, which uses a which doesn't go with the traditional linear regression processing, and you will need to go for a non-linear prediction and modeling technique using artificial intelligence, machine learning, deep neural network. Then only we could able to address this issue, and we will really moving forward, and coming years ahead we could able to reduce the losses in this domain. So I think what I'm what I am going to now talk about in the coming slides are great emphasis in that sense. And there is a proof. It is not a theoretical concept as a block diagram. There is a proof. Central Water Commission in their report in June 2019 have identified, I mean, all the almost, I kept only one slide here. There are about India, all major river basin have been studied, and what they have identified as a findings when they apply an evapotranspiration model, instead of the traditional discharge with the gauging station concept, they found every basin there is a huge difference in the water availability, and the difference is not on the negative side; it is on the positive side. Say, for example, Mahi Basin was traditionally expected, as per the records, 11.02 BCM average water potential. However, with the model changed, with the space data incorporated, it was 14.96. There is about a 4 BCM of difference or increase to water. And in Sabarmati, it was 3, and after applying the new model, it was 12 BCM. So there is a huge difference, and every basin for that matter. So this is a report published, and this is a technical report being referred also. So everybody can able to appreciate this idea and know, and the need has been justified. So now we find by this way, by applying the proper modeling and ET and space data, we are getting the exact quantity measured, number one, and surprisingly we are finding we have more quantity of water than what we think we are having it. So the sense the resources are more, that means the wastage is more than this slide. What you have shown here as a 65%, it could be more than this. So our losses, we are making more losses. Since we are not measuring it, we think we are making a less wastage, but then it is being wasted a lot. So where is this water going? So, or it is illegally been water theft, or it could be many reasons. So once you start measuring it and put the data in a technical platform online, it could be you can pinpointly say that who is taking it more, and who is not, who is been deprived, and once it becomes an open resource system, probably you could able to have a better control. Surprisingly, as I told, India is the country among, I mean, now so far we are talking about within the country. So even if you say internationally, the hectares of land, irrigated land, among Australia or China and Europe, Africa, everybody, India has the largest area. And average distribution losses in the irrigation system, India leads number one. So then China and many other countries, US, so many other countries. So we need to, we are learning so many things, but then we need to learn this, how, what technology is being adapted there. So the technology, what I am talking here, all the papers are the concepts which are being taken out from, mostly from Australia, Israel and China, the practices. So these things will go very well in hand with our Indian irrigation system also. Hence we can easily take the technology, rather you calling it copying, you can able to adapt the technologies which has been followed in Australia and Israel. In India, we can able to manage the resources effectively. Okay, so now it is been proved, it is in the other domain of the computer science domain. If you say till 2012 or so, the computing capacity was not very powerful. So when you start making a model running, the computer hangs. So though you are given with a lot of adequate artificial intelligence data, you cannot train the computer because the computer is not capable of handling such a huge data. The data processing speed and the space it could not take. But then after the supercomputing concepts, the machine learning concepts, after 2014 onwards, and hence what happened till 2012, the ANN based trainings does not work always. So at a very convenient boundary conditions, your predictions go good. But when it is going to a non-linear domain, your predictions miserably fails, and people are afraid to use this type of artificial intelligence concept, which is not true today, which is been much faster. After 2014, no, all the experiments or none of the experiments could prove human prediction is better than a machine predictions. In 2019 and all, you can see all the research findings. None of the research findings could prove human could able to predict better, especially in terms of almost in all domains, especially in water resource domain. Every prediction of a human is much weaker than a machine based decision making in a disastrous conditions, provided the machine is being trained adequately. And today training is very possible because of the availability of the space data and the computing power. These are the two key points. So today you can take up this. So I advise all the teachers, encourage students working on this domain. You can always contact CWPRS or our scientists for any support in this domain or for some data availability, maybe some joint collaborative works, or to assess our our facilities here. Okay, so the past, so we started with, so we think computer is artificial intelligence. No, computer is the old generations. Then comes the concept of programming. Then comes the data being accessible through a concept of internet. Then comes the artificial intelligence, in which it started for natural language processing, then machine learning, neural network, deep neural network. So so you write an equation to start with that, then you improve on it by the machine teaching. And now today's scenario is just given input and output and tell the model it is of linearly related, non-linearly related. Water level is linearly related to the discharge. You can say that. You can say it wrongly also, but then after 2-3 iterations you'll come to know. You can remove it, you can change your decision. The computer will decide and it will suggest. So the future is going to be on this domain. So even if you don't like it, the technology is not going to leave you, or you will be outdated. So it's the right time. You have to pick it up and then go ahead with this. And then what you are talking in terms of equations to making graphics of QGIS, mic softwares, all these software packages are being developed by the computer scientists for you in civil domain, by taking your equation, adding an artificial intelligence and the machine teaching concepts into it. All these softwares what you use in today's models all use deep learning, and the base equations is actually stolen from you people what you have developed. So instead of using such a softwares, you develop your own equations, and for a student project at least that you can do it, and you can have much better learning rate and accuracy than what is being traditionally been followed up. Okay, then here I have shown some of the data being transmitted to a domain of expert place, and communication is being shown here. Okay, right. So the same thing what we have talked about. So an input data is given, model is a real system. Machine learning is a data driven. You are teaching the next instance of input to the machine, and the machine understands, oh, if this increases, this is decreasing, so this is actually linearly and increasing, this is a logarithmic relation, and it corrects the model. So only the initial language you give it, initial relations you give it, remaining things are getting hooked up with that. Okay, so in machine learning, we'll have very simplest one is the neuron based model. They're all multiple input to single output. A neural network, it's a neuron, and you can have multiple layers of neuron, and you can have many other things, multi-layer perceptron, support vector machine, deep networks, convolution neural networks. I think many of you heard about it. This is a concept evolved for artificial intelligence for eye image processing and other medical imaging idea, but then they are very much applicable to our water resources. The blood flow is no way different from a flow in a piped flow also. So if you could able to detect the blood flow of, during an operation, and if you can able to understand what a cancer, to classify a cancer cell from a normal cell using an acoustic imaging, the same is possible in water resources engineering to measure the water speed and discharge, and also you can classify the material below that. Okay, so recurring neural network. So here you can see this is in terms of a sound. It is all been evolved for a sound synthesis, whereas it can be used in a prediction of real-time time series forecasting. Here you can see this is very close to a runoff. This is a runoff modeling. You train the network. If it could able to catch up with all the peaks, then it could able to predict it within those domain in the next instance in a proper way. So this is a linear regression model where it could able to classify between two types of objects, right? So the output of this particular single layer neuron can able to give that. So in case if you have some of the classes available at this side, you may have to make this a non-linear one. So there you need to have a little more intelligence, but then somewhere you have to start. You start with this and you will end up in a very and with very, it is not very difficult, with much simpler efforts, because there are software tools available which will give all these models as functions. What you need to do it is have a subject knowledge, and with the feed what data to relation to the other data. Like you need to correctly map the input to the output. That is important. Say for example, the sunlight intensity to discharge, if you try to relate it, probably it is not a proper relation. So the network will be overfitting, or will try to give erroneous data. So you need to give the proper slope, sediment characteristics, rainfall, then maybe you can see the water level, the velocity. These are all the inputs you should give it to calculate a discharge, instead of giving a some other wind speed, etc., maybe which are not directly relevant. So that intelligence is in the student or the engineer's control. But if you could be able to relate it properly, then the system is going to give you a 99.9% accurate. It won't be going towards 100%, which is not a desirable one also. Okay, now time series we have seen. Then similarly, as I said here, this is in an image, you can able to image recognition. So you can see these are all the reservoirs, these are the water bodies, this is a river flowing stream, these are all vegetation. So that type of classifications. Then you can see the data mining big data. So in terms of this is in terms of weather forecasting, IMD and Indian Institute of Tropical Meteorology, they all work on this domain, which is a long way for our hydrologists to go. So we are now at the second stage only. Time series and image recognition are not even completely exhausted by us. So what we can able to do is forecasting the rain, land use, flood classification, decision making, quantitative spatio-temporal information. So all these are in the line. So 1 and 2 are very relevant in today's scenario for a water resources engineer. So what and all can be modeled? Like this is a model what a mic software, what you will be very comfortable using as a mic uses. Mic is completely built on deep neural network concepts only. So it's a very nice software, but it has too many informations for us to use it. But then for a project level of a student level project, you need not go and buy a mic software. Instead, you could be able to develop a simple neuron based forecast system, which may work much better than a mic software also, by using the advanced algorithms what I have showing it here, right? So Mike may not be using all these algorithms. Convolution neural networks are all very new in market, like but it has been already exhaustively used in medical imaging. So you can pick up those ideas. We can also help you out in if somebody is really interested in working on those domains. And here again, optimal reservoir operations. So we give this type of information when we do a bathymetry survey and make the produce the output. We give such type of outputs to the reservoir operators so that they find it very handy and useful, very bit of very useful information for them. And with the DEMs available, not only the reservoir contours, we can give you the contours outside the reservoir also. Many case studies we have done, but anyway, let me not get into all those things. Okay, so this is a classification using GIS, QGIS, ArcGIS, all these GIS softwares, what you are fancy about it, all are using this. But then not even 2% of the tools we will be using for our project. So instead of buying it, you could know how to use it, or you can jointly take up a project with the computer science boys. I think if that type of concept is allowed in our curriculum, I would recommend you will come out with a wonderful package which could able to substitute for RGS type of thing, and which you can able to supply to the student community free of cost for a handy package, for not with so much loaded tools, with the minimal tools of downloading an image, classifying the water body, extracting the contour. It has been done already, but then you can use advanced algorithms like CNN to do it in a much efficient way and much accurate way. I have seen in many of the processings, data processing, we have seen contours getting crossed, or because of the image resolution, your islands are missed out. So all these things you can improvise if you can use a better algorithm. So here you can see classification of cat and dog. This is a very common example, object detection. But nobody will give you a post like this. So it will be a moving thing, and you have to capture the features. That is the beauty of CNN. You can able to pick up the features, ear, nose, tail, and by any angle it can able to. So all these features has to be extracted at multiple times, and which is to be trained. See now here the features of this original image. So what same thing for a dog and cat. Here what we have done is the same area we have taken in multiple angles and multiple lighting conditions. We are taking it up as an input node for the neural network, train it. Once it is trained within the trained zone, see it could able to capture all the water bodies inside it. So this is the trained zone. Sometimes it will, you can do an extrapolation also. This is the training zone. You can do it outside also, but it is always, interpolation is always a good scenario if it is non-linear. Extrapolation is not very good, make disaster. So within every scene you could able to do again one running, one training. See here again. So this type of projects, I have guided some of the BTech students to do the water quality classification also. And I don't know whether I have those slides, but the same idea what we have picked up from Google, and using a Python program. This is a Python code, very simple, line by line it compiles. Here it is classifying the houses, the buildings, road and buildings, right? So similarly, I can able to classify the water quality also without touching it. So these are some of the steps what we followed. But talking about so hi-fi, but Jupyter is a notebook what we used, and we used ArcGIS to extract this image and use it for training with the Python and classified it. Now to do this, are we ready to take up such challenge? So this is a photograph which I also always show in my presentation. Somebody is putting their head inside to show how much water is there, groundwater. So I am not telling we are on that stage, but we are not much better than that. So we are in a very we lack technological advancement. We don't understand. We don't have a concept of multidisciplinary working culture, and so we use our traditional tools to try to map it. Whereas you are having something like this requirements to map everything online at one point. Sitting at one point, you have to have your complete catchment at this particular computer, and just a mouse click you could able to get every node, what is the discharge, what is the rainfall, we are aiming at this. And other thing is, we are like not only measuring, we are trying to predict also. But what is our knowledge base and the tools what we have is this. So we need to improve. So why this improvement is not happening? Because from the curriculum you need to go back and then change.
Sir, we cannot hear you.
Hello.
Yes, sir. Yes, sir.
I mean,
You are
I got
audible.
disconnected. I got disconnected for some time.
Yes, sir. Yes, sir.
How many slides I missed it, by the way?
So you were explaining that we are lacking in the technological development.
This is right. This one.
Yes, yes, sir. Yes, sir. This one, this
Okay,
one.
okay, okay. Just ping me in case if something goes wrong, because though I'm talking about technology, there is a network technology happening always from my side
Yes,
also.
yes, sir.
Okay, so I'll just continue. Okay, so we are aiming at. So how many of you are aware about this type of sensor? So these are all most advanced vibration wire type sensor, which are used in the dam structural monitoring. This is a pore pressure cell. This is an uplift pressure cell. This is an extension meter, temperature cell, a tilt meter. So these are all used in the dam body. So they have a lifetime of about 100 years or till the dam exists. So once you fix it inside the dam body, you cannot take it back. Right. So these are the technology, and this is a weather station. Typically, how it looks like. So this is an antenna which communicate to a INSAT satellite. This measures rainfall, wind speed, velocity, humidity, temperature, and whatnot. You just put a small sensor into it. It measures every piece of data, and then it uploads into an INSAT satellite, which you by a login account and a password you can able to access it any part of the world. This is a typical water level sensors we use in the reservoirs to get the upstream reservoir water levels. Okay, so there are many things. So into the time limitation, I'll go fast into the technology part. So these are some of the acoustic sensors which we use in the. I will tell you one application for this. This is a transit time sensor which is used in a closed pipeline externally. If you have a pipeline, it can be a steel pipe, it can be a plastic pipe, or any type of pipeline. Even your domestic use pipelines, this type of sensor are fitted externally, and then it measures the flow velocity, and it will give you the discharge precisely. And this is the again this is called as a cross correlation flow metering technique, cross correlation. So one transmits, one receives on the other side, and other one again the receiver transmits and the transmitter receives. So you have to cross correlate the mathematics. And here you have a camera system. You can able to just take a video image, and then still you could able to get the velocity. You have a radar type velocity sensor. See, this is a gun, so it transmits a beam, touch the surface, and comes back. Velocity is picked up. So this is a velocity plus water level. This is a bottom mount acoustic sensors. This goes and sit in the bottom of a canal or a river bed or any flowing water medium. So it sends a beam upward, and it could able to pick up velocities at different levels. Right. So there are many ways. So these are all called as the sensing part. Number one is sensing. Even it could be for water quality sensors. Any parameter first you need to sense it. One, it can be a contact based sensing or non-contact. People use propeller type current meters, very standard way of measuring the velocity. But we normally don't recommend a mechanical device which will have a moving parts, and hence it requires repeated calibration. So nowadays you have electronic sensors with non-moving parts, hence the accuracy and these calibration issues are resolved. Now once you measure it, then it comes to a place called as a remote terminal unit or PLC, whatever name you call it, where it will have a temporary storage, and the noise and other unwanted signals are being filtered out. Then the signal is ready for use. From here you access the signal by putting your USB card, or by a communication medium you can take it into a Bluetooth, you can transfer the data, and this data goes to your processing unit where your all intelligent things like AI, ML all will come in, and here a decision is made, and the decision output goes to a finally control element. So in a canal it is the gates, from a irrigation pipeline network. So it is the distribution network controller. If it is a dam, it is the gated dam. So there is a gate control system, and this is a sensor which measures the movement of the gate in 0.001 degree of accuracy precision. So you could able to control that much of water flow into it. Whether you need that accuracy is a different issue, but then you could able to precisely control it. Okay, to brief introduction to how CWPRS can support you people. So we are about more than 100 years old institute with the expertise in each and every aspects of water resources, and we have faculty ranging from physics, mechanical, chemistry to electronics, computer science, water resources, and very talented knowledge pool. Hence, any problem will be understood and then analyzed with the multiple disciplinary concept. So which normally if the colleges also follow, probably we can able to solve many of the national important projects, and we can address about 22 topics as such, and not limited to this. We can take up any of the challenges which has been referred in water resources. So we are so blessed because we are located on the bank of a reservoir, so we have adequate water supply available to our studies. So from the dam, one particular separate canal system pulls in water to us. So CWPRS is one of its kind institutes, very few across the globe, who has a physical model studies. So many things you cannot able to mathematically map it. So it is it's a traditionally Britishers have started this idea, and we are still following it. And India is one of in CWPRS one of the institutes across the world who is still retaining this physical model based spillway studies or coastal projects and many projects using a physical model concept. You have mathematical modeling also, which is normally being now carried out at all IITs and many places. And we have expertise in field data collection on a boated concept, and we have laboratory experiments also. So this is an example of how the coastal model studies are carried out on CWPRS. This is a Mumbai port model. So here you can see huge discharge has been pumped from a sump of about 2000 liters per second is pumped into this Bombay port model, by which you could able to create the tidal effect, which is happening inside the Mumbai port, by which you could able to control the design the jetties and your ship motions, all are taking place. So this model is existing since Bombay model existed, and it will remain till Bombay model upgradations and new jetties, new breakwaters are being designed there. So such type of studies are a huge revenue making and very important for the nation building. So though this the concept of model looks very attractive, but the basic element of your tide generation is the automatic gate control. So unless otherwise this gate control technology is not precise, you cannot able to reproduce the tide what is occurring in nature. So what we use here is a concept of PID. When you operate a mechanical device, you don't get a smooth control. You'll have overshoot, you have undershoots. So all these things has to be controlled. So it is a proportional, derivative, and integral control combinations by which you come and get your required operational condition after a time period of TS. But here in a tidal process, the process changes between TS. So hence it requires a higher intelligence. So a traditional proportional integral derivative doesn't work here. So we go for a fuzzy based controllers where this artificial intelligence plays a big role, because within TS your set point also changes. Here I kept a constant set point, right? So these are a lot of challenges. So now you see that your set point is changing continuously, and your reproduced green color also is been tracking it. So it changes accordingly. So the actual water level 5.95, required water level 6.14. So this is an automatic tide generation system we provided for Kolkata Port Trust for Kolkata. So CWPRS support the other port activities. We will take it up at our place as well as we'll give it to them also. So this is the SCADA based system, supervisory control and data acquisition, where a software is developed in-house, where by a mouse click I could able to get a river discharge at this point in liter per second. So this is Taloja River, Gadi River, Kalundri River, Ulve River. These are all some rivers in Mumbai, which is discharging water into the Panvel creeks, near to Panvel Creek. However, this particular zone is being now proposed or already been developed as an airport runway. So the complete study was carried out here. For that, based on our study, we recommended one river diversion and exclamation of this much of sea portion. Now this is expected to push in additional water into Panvel, and some areas may get inundated, but then the study has revealed the safe margin and according safety measures have been suggested. So these are all some of the advanced measurement by which we could able to, even with the physical model study, we could suggest the client, and these activities are already started. The runway activities are already started in Bombay, and whatever predicted by CWPRS is actually happening in field also. So they are successful. The same has been mathematically also studied by IIT Mumbai, and the results were closely matching. So these are some of the dam instrumentation sensors what I have shown how they are used. So I'll get into some of the applications which will be interesting for you for your student level projects. I will complete my presentation by 11:15, and we'll have some 15 minutes of question and answers. So by 11:30 I'll wind up. So in case if you have some questions, type in or keep it ready. Another 15 minutes I will close it up. Okay, so this is a bathymetry survey work what CWPRS take up to measure the depth of water bodies. So these are the measured depth 11.4 meters. So this type of data and all we can share you for some student projects. Bathymetry, huge data we have at many sites, multiple time survey data. So by which you could able to, you can find out a nice problem for that matter. Okay. Now, any efficient management system requires. Now, let us assume present canal systems in India has a 50% loss on transport. It can be improved if you have a complete automation, which is called as, I call it as a SCADA. Then the measurement technology with some intelligence incorporated into it, you get another 10% improvement. Then the open channel, if you bring it to a closed pipeline, you are expected to increase. So by these steps, you cannot go from here to here directly. So you have to go in stages. So in the coming days, so what is not inevitable is you have to measure, you have to use artificial intelligence, and you have to change the way you irrigate. You know, your mindset change. These processes are very, very important in the coming days to increase productivity. So that is again a management. It is applicable to a domestic irrigation network also. You need to apply an intelligence into it, and you need to have a proper measurement, not a prediction, a proper measurement. So this is the ADCP what I have talked in the first slide. So this is actually we are measuring a cross-section profile of a canal. See, our engineer is pulling it across. So the sensor having sound beams, which is measuring the velocity, and you get a complete profile. So this is the most accurate way of measuring as on today's technology, a contact most accurate measurement. This is an unmanned, like, you know, here, this is a better technology where a human intervention is not required. You put the sensors inside the walls, so it keeps on measuring automatically. Then this is uplooking thing, which I have already explained you, which sits at the bottom. Only thing is the concern is in case if it is huge sediment is expected, then sediment will come and sit on it. So you have to take it out at regular interval and clean it, or you can send somebody in and clean it in case if it is not very deep. And what you get is the discharge directly at velocity. You know, these are actual measurements carried out in Karnataka at one of the sites. And some external measurements. This is the way you make, if it is a pipe flow, you can do it an external measurement. The bottom. So these are some of the case studies where CWPRS has actively participated, where the disputes are resolved by applying a proper measurement system. That's all. We didn't do anything. The system remained as it is, but there is a dispute. This is between Telangana and Hyderabad. So the dispute resolution is somebody claims I am not getting the adequate quantity of water what is promised to me. So we change the measurement system. Okay, so let me not get into it, but basically the problem lies in the measurement. So we change it to a proper measurement, by which, you know, we can able to get you. These are some practical things, but in a student level, maybe you can able to come out with a different algorithm or technological advancement. This is for Narmada Canal. This is Gujarat, and this is Rajasthan. Here again, a huge dispute is going on. So we are working on it now. So I'll tell you what all the things proposed for them. Now, a complete automation is something like this. This has been happening in India and in Karnataka in Krishna Basin at one place. The farmer can able to demand a water based on the crop what he has put. Now, like this, multiple demands will go to the server. Now, the server will analyze the water available at the reservoir or the storage place. Then it will understand how much the demand at every node, and accordingly distributes based on the priority and the reliability. So in case of the farmer says I have sugarcane and he has not put sugarcane, it will be verified from a satellite imagery what has been put and what interval. So it will be cross-checked, and accordingly the flow will be regulated, and you get a equal equity distributability to all the place. So if you have only X volume, X divided by 1, 2, 3, 4, 5. In case if you have Y volume, accordingly. So nobody will be given any priority in that basis based on his demand and things. So this will resolve many disputes among the farming community also. Okay, so these are all some of the things we are working on with IAA. Already this work is started. We are already working on for the state governments to have a optimal irrigation. So this is not a theory. This is all being happening, which has been happening in other engineering disciplines. Is been now followed into water resources discipline. That's all. This is how the DEMs or elevation contours we overlay after downloading from the satellite imageries, by which we could able to give you a nice plot like this. And we have used this type of lidar systems. This is a light laser based contour mapping. So in case many places the satellite contour resolution may not be adequate 30 meters. So here by using this laser light camera technology, you could able to get even a centimeter level of contours being created. But only thing is you need to take it on a vehicle and then run it. So it has a swath of about 100 meters on both the sides, or either you can put this payload on a drone and you can able to run it also. These are all the things happening when defense establishments are using it. Maybe for our requirements, probably this much accuracy is not required, and hence we are not very much using it, but technologies are available for us. Okay. So these are some of the survey things. Let me come to some of the technological advancements in today's scenario. So these are some of the data products available for us from Indian remote sensing satellites. This is from an European remote sensing satellite where this particular satellite CWPRS has used extensively, which could able to give you 10-meter resolution at repetitive of 7 days free of cost. And for ocean monitoring, like we have a Sentinel-3. So these are all free satellites by an European agency, ESA website. People can try it out. So you have 5 days repetitive. This yellow are all 10 days repetitive. So India is covered in 5 days repetitive rate. So this is the image I have shown in the first slide. Here you can see that the reservoir color gradation from a satellite imagery gives an absorption coefficient of 364 to 987. When I trained a neural network, it has been converted into 5 meter to 9 meters. So the bathymetry of a reservoir is extracted from the absorption of sunlight captured by the satellite. So how it works? So we have this is not a concept. This has been already proven and validated at 3 sites across India. Now we are working on this same concept to evaluate at multiple locations, and finally this will become a standard for reservoir bathymetry survey also in the maybe in the coming years. So how it is all possible? Because we have a platform called as Google Earth Engine, where the codes are available, and we get a virtual supercomputer. When you get a login, it is free of cost. Google Earth Engine gives you free login. When you log in, what happens is your code and data runs on a supercomputer in the background, which is a computer provided to you by Google. So your screen is only just to see the results, but the processing is happening in a much faster gigabytes or flops, gigaflops of computing power. So you need not worry about I have a very low speed computer. How can I do that? So this is all possible with the Earth Engine code editor. And the Earth Engine supports Java and Python. So these are some places where you need to adapt yourself to learn these languages, or you have to get a joint projects with the expert guy who is aware about Python. So now this is a study area where, see, this green portion is the bathymetry actually measured, and the brown portion is actually predicted. So from the predict, you can see the band ratio relationship. You could able to get a regression coefficient, and we could map the complete reservoir body with its depth profile in terms of 5 to 9 meters depth classification. What is the advantage? Once you classify it by the measurement, you could able to predict it for every 10 days the siltation taking place. So you can take up such studies in your area, and you can able to do that. So these are all some of the regression values. So we used, as I told you in the initial things, multiple algorithms. So every algorithm had a different accuracy. Since I am not an expert of the water resources, I applied all the algorithms, and we have found the model prediction to the ground truth. There is a huge error throughout. by a logistic regression. So when I applied a deep neural network, my error come down precisely, and I could able to get a very accurate, precise measurement. So here you can see in Jharkhand we tried a project, so where without actually surveying we could able to get the absorption coefficient. Now what is required? Any one of the reservoir, I will take my boat and then I will get the measurement and then fit into this absorption. Then all the reservoir profile will be reproduced in terms of depth instead of absorption. So that's the beauty of it. So in one scene of about 200 square kilometers, I will survey only one water body, and remaining water bodies are automatically generated. This looks little imaginary, but it's all the factuals what I am quoting here, right? So here again you can see this is called as a legend bathymetry. Legend bathymetry means we don't know what is the depth, so we have created an absorption coefficient. Now if I go and say this red color is 2 meters and green color is 20 meters, then the system will actually predict that. Okay, so now let us go into another interesting aspect. So here you can appreciate this is a student project, MTech level student project, where a camera is image is used, which we have patented also, but you can have multiple ways of doing it. So you can see this camera capturing a movement of the particle, by which I could able to get the surface velocity. This is inside CWPRS canal, and the direction of flow and the velocity you can able to capture, by which you can able to get the discharge. By using advanced mathematics, you can get from the surface velocity, you can go to the velocity at the bottom, and hence you could able to, even you can use camera so that in the night also you can able to capture the cross sections. This is a project where water quality has been by a BTech level work only, but a water quality between different imageries can be captured in time. Okay, so this is in Ganga River. So similar studies are possible by, we can help you out. This is a laboratory study where a suspended sediment concentration and classification of sediments from an image processing. This is a disaster movement using some modern measurement techniques. These are all mathematical models. So these are some of the field evaluations. This is Gagra barrage, where it is very difficult for us to go and get the cross section profile. So an image processing method has evolved to get the profile of the reservoir from an image, not by measurement. So now in the canal also we are extracting the profile of the reservoir and the canal bed by the image analysis, by which you can able to see whether any sediment deposit is taking place. So here you can see this portion, there is a small deposition, maybe some vegetation, some this can be monitored. So when there is a discharge dispute between both the sides, you can always say where it is getting slowed down, the velocity getting slowed down, and so many other things which are not relevant for a student level things, but which we could able to do it for client sponsored projects to feed the bed damages in spillways and all. So what is the important conclusions is acoustic and image processing with the satellite data, with the artificial intelligence, all the future technology. So let us recommend this and encourage the students to develop their skills on neural network and deep neural network, so that we can able to do the traditional or your intelligent work in a much efficient way, and maybe in a national level you can able to contribute something. So what is the conclusion is, you don't go to the site and then use traditional sensors. Just see it from the space with multiple eyes. Multiple eyes means multiple bands of viewing, and with an artificial brain, everything below looks simple and solvable. Once you measure it, you could able to solve it also. So thank you so much for the patient listening. Now I will take up some questions if you have understood something. So thank you so much.
Thank you so much,
Is
sir,
there?
for the
Yeah.
wonderful and enlightening talk. Are the participants having any doubts? They can unmute themselves or even type in the chat box.
Yeah, if there are some questions in chat box, madam, you can read it out. I am not seeing the chat box.
So as of now, I cannot see any questions. If the
Okay.
participants want to interact or if they would like to ask any of the simple questions, you're most welcome.
Yeah, CWPRS take up student projects also, so we can support you by providing some data, or we have a lot of physical models. Your students can come here, stay for some time, and then carry out their experiment, and then you can model it and then verify it in a field condition. So this is a nice work for an MTech level or above.
So does CWPRS also provide training to students for graduate students?
We conduct in a year, we have about some 30 to 40 training programs which are free of cost. Even you can see our website, all those things. Even right now, there is a training program happening on flow calibration, cavitation flow for a powerhouse. So it is going on right now. Even yesterday it started 2 3 days. Normally we conduct it at CWPRS. After this pandemic, it is kept at online. These online things are completely free. When you come here, the travel expenditures you have to burn, but the training will be normally free of course. And we have a our co-institute which is called as a National Water Academy, which is in our next campus, National Water Academy, which is a mandatory institute to conduct training programs throughout the year, completely free of cost. Everything is free. For a government body, in case if you are a faculty, you are given a free. In case you are a private person, you may have to pay. Those are all very advanced trainings. Like you'll be given a hands-on Google Earth Engine, how to operate. Even civil engineers only teach it, and we will be faculty on that. You will be having programs specifically to power house on discharge measurement, environmental monitoring, many aspects of your what you study, because these are conducted by Central Water Commission. It's a mandatory protocol. National Water Academy is bound to do that, and they do it free of cost. They have accommodation available. It's a nice guest houses, a mess available. So maybe very soon, I think they will revive it back because of the Corona things. It is all happening online, but still you can register in National Water Academy website also. For that matter, online things are free at CWPRS, but then when it happen to come here, we charge you. Whereas in National Water Academy, don't charge you for a training. And we can give you a very specific program also, in case if you identify some 10 faculty or some engineers who wanted to be trained on a particular aspects of water resources. So how to calibrate certain things, how to work on a canal modeling, how to work on a river flow, gauge discharge calibration system. So we can give you a field experiment with the stay, and with the equipment we can able to train you with hands-on. So these type of facilities we have, but you need to be in touch with us and we can support you that. So yeah, thank you. Anything else?
Yeah, any of the participants would like to ask anything to sir?
I expect if students, it is okay. They are faculty, so there should be some doubt created. I thought I had touched upon some key topics, but I
Yes,
could
sir.
not provoke any neurons of any professor's mind, I hope.
No, sir, actually, this is a very new field for us in
And
which
that's the
the
problem.
people
It should not be a new
practically.
field. It should not be a new field. India is lagging behind. We should
Yes,
have
sir,
China,
definitely.
and if you see the publications in IAHR, you can see Japan, China, Korea, US. They are all like in competition. We are lagging so behind. So that's
So
the sad.
probably that is the reason why nowadays the new education policy has introduced this coding at very early stage.
So this type of awareness programs are very, very welcome. More number of programs to be encouraged, so that the faculties are to be first sensitized.
Yes,
That's very
definitely.
important, and you need to join hands. Probably Narmada control problem what we are facing, we would like IIT Gandhinagar to take up the work. So what happens is their civil engineering electronic faculty can easily work with the Narmada department and they can solve it. Similarly for your things, the Narmada flowing in your domain, you join hands with the IIT Indore and the irrigation department. You'll be getting a big problems sorted out for the department who are now unable to tackle it, and they refer to us. And CWPRs one across the whole country can't take up everything. So even we look forward for such a joint model. You can always contact us as a support or a supervision, not the complete work. We need manpower. So students are the biggest potential we find it today. Your college also, you may have a computer department.
Yes, sir,
Those
definitely.
professors will be working on artificial intelligence, on something else, whereas they can solve a problem of a Narmada flood.
So, but
Yeah.
what the problem is these days that computer science is a separate field and then these water resources is a separate field. But what you had introduced that there is a multidisciplinary approach in which computer science
Exactly.
was also involved with that water resource
Exactly.
modeling.
Computer science professors look for data, and you have a lot of data, and they have an algorithm. You don't have that algorithm. So this
Definitely.
amalgamation, if it happens, you can have published many potential papers. And Narmada River is that thing is not available across the globe. You get a very unique land terrain there. Narmada is such a thing, and you have multiple dams. Indira Sagar, Omkareshwar, Maheshwar. The flood routing. I think that comes in my MP, right? So yours is
Yes,
also in MP.
yes, sir.
So in Indira Sagar, Omkareshwar, Maheshwar, the three in loop controlling, nobody knows how to do that. So every flood, every monsoon, we create a huge flood. So you can take a part by part, and in case if you come out with we can jointly also do that. Like just look into those aspects and water quality aspects, management aspect. Many things are there.
Yes, sir, definitely.
Right.
So one
Thank you.
thing I personally had a problem that I tried to get the data from the Sentinel website, but I was never unable to. That I would like you to guide me regarding it personally whenever you have time, not right now. So
Which
how can
data,
I?
madam? Which data?
So actually, I was trying to get some air quality data from the
Hmm.
Sentinel website,
Okay.
but I was maybe I was missing some part because of which I couldn't get
Okay.
that data.
Yeah.
So I would
See,
request you to.
air quality, I have not directly worked, but we have a tie-up with IITM and Indian Meteorology Department, Pune. So I'll talk to those people. There are, they are dedicated team working on it. I'll find out and give you the right information, or I'll put you in touch with the proper scientist who is doing this work. So
Thank you.
it is being done in Pune itself. I will put you in the loop. Thank you.
Thank you so much, sir. So any of the participants, if they would like to speak to sir, we encourage you to please interact because that motivates us.
Maybe you have not activated their mic. Is it something like that? Just check out.
So I think they are allowed to
Okay.
switch on the mic. So I would like to thank you, sir, personally, on behalf of the IPS Academy, Civil Engineering Department, Institute of Engineering and Sciences, for wonderfully enlightening us regarding this multidisciplinary approach for the water resources. And we are privileged to have you with us today, sir. We look forward to having interactions with you sometime in future again, sir. Thank you
Thank
so
you so
much.
much for keeping me in this program to share our experiences. I would love to have more interactions with all the
Definitely,
faculty in the future. Thank you so much.
definitely, sir. Thank
I'll
you so
leave now.
much. So the participants are informed that today we had this session scheduled a bit earlier because Selva Balan sir was having some urgent meeting, but he didn't wanted to miss this expert. So we rescheduled it a little half an hour early. Now we will have a break till 12 p.m. So at 12 we will be meeting again for the next session by Mr. N.K. Kuttiappan. He's a NABET expert from the Quality Council of India. So we will be meeting again at 12 p.m. Thank you so much. Shall we start, sir?
Yeah, yeah, please.
So I welcome all the participants to this day 3 session 2 of AICT sponsored 1 week online short-term training program on water quality complication, restoration and environmental conservation of existing water bodies, Module 2. And we have with us Mr. N.K. Kuttiappan sir, who is a postgraduate from IIT Mumbai. He is an expert from the NABET, Quality Council of India. He has been working for around 26 years in that, if I'm right, sir. So he is also an environmental engineer. He has also been an environmental engineer with Grasim Group of Industries, Calicut, Kerala. He has been working with the National
Yeah, there is some internet problem.
Sorry, sir, I think there was some connectivity issue.
Yeah.
So he has been working with the Indo-German bilateral project at different levels to promote pollution prevention and control services for SME and large corporates. He has also worked with Shriram Engineering Construction Company for the turnkey environmental projects. From 2000 onwards, he is running a proprietary concern, LBK Enviro Consultants. He is empaneled with NABET, Quality Council of India as Assessor for EIA Accreditation System, empaneled with IRQS for ISO systems, and also with Environmental Training Institute, TNPCB, Chennai. We are honored to have you with us today, sir. And on behalf of the Civil Engineering Department of IPS Academy, I welcome you. I thank you personally for taking out time from your busy schedule and being with us today. Thank you, sir, and I request you to proceed with the session, sir, please.
Yeah. Thank you very much. Thanks for elaborate introduction. And I will now go ahead with the session, and I'm just sharing the slide. And just in case any problem, you can just tell me. I hope it is now connected. Okay.
Yes, sir. Yes, sir. It's clear, sir.
Fine. Okay. So, good morning to all of you. This session actually is packed with almost 86 slides, and I will be spending time in some slides more, and other slides I may go through fast. But overall, what I will cover is the concept of wastewater treatment and how to cut cost through technological angle, how the people have come out with various technologies in operation maintenance cost cutting or competitive way of putting the technology, and followed by maybe one or two case studies. That is how I structured the session. And so the topic is trends in biological wastewater treatment, the challenges and opportunities. Because water is one of the topic very much going very strong. And I always remember when it comes to environment, I refer this the ex-president Excellency Theodore Roosevelt's conservationist. According to him, this is the quotable quote. I have a very strong admiration to this quote. It goes like this: the chain of cause and effect is what makes up the environmental web of life. The actions, reactions, and non-actions. I stress particularly non-actions. So the actions, reactions, and non-actions of people are what make up the human web of the society. The interactions between these two worlds will determine both our natural and social worlds tomorrow. I mean, a very strongly worded, but I find a lot of meaning even beyond, let us say, sustainability issue. When we come to water management, we need to somehow have economic way of how do we classify. From an engineering perspective or an implementation perspective, I not only me, even world over, they divided from hydrology point of view. Large users means more than 15 MLD, medium users 3 to 15 MLD, and small users 500 to 3000 KLD, and tiny users less than 500 KLD. Why this is required? The art of technology will go by the flow rate, because the hydraulic profile is linked with how complicated is your hydraulic regime. Accordingly, engineering way, we divide the size of the wastewater treatment into these four categories. And whatever water we tap, it's all ultimately after usage becomes wastewater. Okay. Now, in order to protect our hydrosphere, the regulatory agencies, they classify the infrastructures for purifying the wastewater into one STP, sewage treatment plant. The sewage treatment plant is most easy to treat because it doesn't have other than pH, COD, BOD, TDS, etc. That means if you want to really promote recycle, it is much easier to handle the sewage. And incidentally, if you look at the total water consumed, Indian perspective, nearly 70% of the volume is constitute the sewage, and we are yet to handle that effectively. Okay, the sewage is still not treated across the large metropolitan, forget about the small cities and towns. Then comes the next one, effluent treatment plant. That means mostly for commercial and industrial application, whatever water used, they reappear. And there's a lot of focus on ZLD, zero liquid discharge. But it is most difficult to handle because in an ETP, we do have something like there could be specific anions like cyanide. It could be ions like heavy metals. It could be even specific organic, which goes into non-biodegradable, volatile, recalcitrant, etc. These are the complications when you deal with trade effluent. Easy to attempt zero liquid discharge for sewage, not so easy to approach ZLD in the effluent treatment plant by and large. Then we also have another concept called CETP, that is Common Effluent Treatment Plant. This concept came in India way back in 1990 with the World Bank support. Okay, that means all the small and tiny industries on their own they cannot handle it. So why not on cluster basis bring them together and let it be managed? And then a lot of efforts were done to fund and also make sure. Normally, if you just go back the concept, World Bank came with the idea central government should support with 25% grant, and the matching fund should come from the state government. That means 25 plus 25, 50% is available from the government support. 40% is the one financing route through the bank. That's where the World Bank was very keen. Okay, and only the 10% is required by the member units of the CETP to invest in. So this is the concept by which the CETP came way back in 1990. And we have more than 400 such CETPs across the country. Okay, here also the spatial collection of, it could be also CSTP, that is Common Sewage Treatment Plant. Like in a hill station like Kodaikanal, all the hotel, instead of having it individual, all the sewage will be brought to a terminal and treated. This could be even applied in a industrial cluster, because most of the SCZ, what is coming up nowadays, all the polluting activities are outsourced, and they do only something like non-polluting activity, and you end up with mostly sewage. So even that concept you can say as common STP. Okay, and here also easy to promote if it is CSTP, but not so easy to promote ZLD with a common effluent treatment plant. So whether it is an STP or ETP or CETP, they are all supposed to protect our hydrosphere, to secure the maintenance of assimilative capacity of our various receiving water bodies. And it is very important at this point to stress one issue. Globally, water is now color coded into green, blue, and gray. What does that mean? Green means exploit rainwater. That is what? Color coded rainwater, green. And blue means minimize the extraction of both surface water and groundwater. Okay, minimize. And gray means exploit, reuse, recycle. So that is how we close our water cycle by color coding. This is an international color coding, and it is ending with water footprint. So water footprint means what? If I'm an industry, I not only look within my manufacturing boundary, but I go beyond the boundary, because there is a life cycle kind of a concept. Even to procure material, those material also undergoes production process. So just to give an example, to make 1 cup of tea, you need 5,000 liters of water if you apply that concept of water footprint. So this concept is now coming up across the globe because water is becoming a dwindling resource, and so we need to understand the concept of green, blue and gray. So exploit green, minimize blue and promote reuse recycle of gray. So how do we do that? So we can do this through an aerobic route of treatment, an anaerobic route of treatment, and facultative route of treatment. This facultative route of treatment was my first session handled some months back. And in this session, I will be talking more on the aerobic process. You all must understand this entire wastewater treatment. So when it comes to biochemical route, it goes with something called Krebs tricarboxylic acid cycle. What does that mean? The entire treatment is biokinetics. Okay, so we don't use a term called biological oxygen demand. Once it used to be, today more the term. It is called biochemical oxygen demand. That means everything is an enzymatic process. How the organics is used as food by the microorganism, and that is converted into carbon dioxide water when it is biodegradable. If it is not biodegradable, then you have to think about alternate system of treatment. Now, when you look at the process, what we call, nature is always disordered to order. Okay, disorder to order is actually not the nature. I'm talking about the biochemistry. Whatever junk food you eat, your body knows how it should be systematically accumulated in your body system. That is why I call it is disorder to order. Whereas all the man-made activities is order to disorder. That means the man-made activity is following the thermodynamics principle, but your biochemical process is not following the thermodynamic principle. And this is one of the important feature of bioengineering, biogenetics, or whatever you call. Very, very systematic way of degrading the wastewater. What is the aerobic process? It's nothing but CHON is nothing but organic. This organic is measured in terms of COD, BOD and total organic carbon. And that when it is consumed by the microbes, it's converting into carbon dioxide and water in the presence of dissolved oxygen, and it generates new cell. That is what we call the growth process. Okay, I take and my body grows. So there is this entire process in less than few seconds. The generation time is in seconds to minutes for the microbes. And aerobic process means it is an exothermic. On the contrary, anaerobic is an endothermic. So this process will take place only when there is a conducive environment. What is the conducive environment? pH should be proper, temperature should be between 17 to 37. Macro and micronutrients must be present, dissolved oxygen must be present, there should be absence of toxicity, and the salinity, that is in terms of TDS. So salinity is chloride. In terms of TDS, it should be less than 15,000 milligram per liter. If it is more than 15,000 milligram per liter, you can expect the biodegradation will not take place, which is the case with most of the dyed intermediates, bulk drug, etc., where the process inherently is high TDS based. So anaerobic process, it's a 2 or 3 step depending on what is your starting material. So your starting material in our wastewater is nothing but liquid. All are soluble organic. If you are talking about sludge digestion, then it is a 3-phase because the solid should be undergoing liquefaction followed by hydrolysis, fermentation, and then methanogenation. So if you look at the same organic, I need the same microbes, generates actually carbon dioxide water, but then volatile acids, new cells, and all the other things will, like sulfur will become H2S, nitrogen will become ammonia, and it is an endothermic. So when you compare the aerobic with anaerobic, anaerobic is actually converting into valuable resource like methane, second step, and less production of the biomass. Net production will be less, but the efficiency compared to aerobic will be less. Okay, so anaerobic process generally used for highly biodegradable waste in terms of BOD preferably more than 2500 milligram per liter. Okay, if it is less than that, then choice is also coming. So just giving an idea. And now when we deal with only the sewage, okay, these days the government is also very serious in promoting reuse recycle only, not the concept of only treatment. We are not interested only in treatment. So the standards have undergone change. So we are now talking about recycle grade means I'm talking not BOD, COD. So COD should be brought down to less than 50 and your total nitrogen should be brought down less than 10 and you have to even prescribe the fecal coliform which should be less than 100. So now this is something called in the township and in our industries, we are all talking about treating the sewage and meeting the flushing grade. Okay, most of the EAA project, invariably the project will integrate the toilet flushing will be met through the recycle grade. Even the National Building Code of Practices and the CPHEO manual, that is Central Public Health Engineering and Environmental Organization manual, they all now promote. We didn't have the flushing standard earlier and today we have the flushing standard. What does that mean in terms of technological understanding? I cannot achieve this unless you go through carbonaceous removal, nitrification, denitrification mode of treatment. So the moment we talk about treating for toilet flush grade, your treatment approach has to be necessarily following carbon removal, nitrification, denitrification. Then Ministry of Environment Forest gave the standard unilaterally saying that all the metropolitan cities should follow. There were a lot of resistance because we don't even have the conveyance system, that is underground sewer system. But why do we talk about recycle grade norms so suddenly? Then the ministry understood that is a mistake, then they modified, then they made it, okay, let the CPCB in coordination with the various state pollution control board institutionalize where the reuse recycle required, let them follow this norm. But for the cities, we will follow only the disposal norm. So that disposal norm has undergone change. That is how I am highlighting this because this also NGT also stepped in. Okay. Yeah. So that is this. When you look at the pollution control system, when we deal with water pollution control, we need very good understanding of the flow and the characteristics. Whereas in an air pollution control, apart from that, the property of the gaseous pollutant also required. But anyway, that's not our intention here. But when we deal with an industry, the moment we want to know flow and characteristic, it is better go inside the manufacturing process. Try to see where the pollution can be minimized at source. That is what we call in-plant measures. Then you formulate the design inputs because don't jump into whatever the client says, put up an ETP because it's an expensive affair. And then talk about am I meeting the treatment requirement only for compliance or for reuse recycle? And increasingly I'm saying gone are the days where you are designing the system for compliance and today it is beyond the compliance. Okay, that means reuse recycle has to be. And again you recollect the color code green, blue and gray. So this all articulates only reuse recycle, not compliance mode. So this compliance mode, when we talk about flow, is actually deciding the capital and the load is deciding about the recurring cost. So that is the reason why the characteristics, if I am playing good role inside the process, I can minimize my operating cost. Okay. And whenever we put a water infrastructure, that is STP, ETP, CETP, from ISO parlance, we use an acronym called BETNEC. What does that mean? Best environmental technology, not entailing excessive cost. In simple term, if a treatment can be accomplished in 4 steps, why are you giving 10 steps? Okay. The consultants generally what they will feel, put the more number of sequences and complicate the operation maintenance. So that's an area now growing. It's a retrofitting business. Okay. So why should I have a number of treatment steps more than the requirement? Minimize the number of steps so that my operation control becomes much easier. That's called bent neck approach. So to simply say, any water infrastructure will go through pre and primary treatment, biological treatment, or rather I should say biochemical treatment, then advanced wastewater treatment. But most important, you should always remember, matter can neither be created nor be destroyed. Whenever we talk about a water infrastructure, the associated sludge also should not be ignored, because the wastewater sludge is also part and parcel of treating the effluent. So somebody says I have a very good treatment, then I ask him what is the extent of sludge production. No, my process is so efficient, I don't produce any sludge. Means you'd have to take with a pinch of salt. There is something wrong. Okay, now this infrastructure I can put it through a project based or a product based. So what is project based? Now the project based is something like I engage a consultant, evolve the treatment process of technology, prescribe the bill of material and bill of quantity, and go through the tendering process, nominate the vendor and execute. So this we call as turnkey project. Okay. A project based is always a turnkey project, and generally it is required for medium to large application, because there people would like to have a competitive way of evaluating. But when you talk about a product based, normally this is meant for up to, let us say, in US up to 3 MLD, in Japan it is up to only 0.5 MLD. In India we don't have something like that prescription, but you can also follow. Okay, in my opinion we should say 1 MLD. Okay. So what is that product base? It is a pre-engineered package solution. That means when you want to buy a boiler, you tell what is the capacity of your steam requirement. So the manufacturer will supply everything and install and produce. Okay, something similar concept you tell, and generally this package sewage treatment plant is for the sewage generally. Okay, you can apply for industrial also, but I should know in advance they are all biodegradable, moderate to high biodegradability. Okay, now this generally you can say hospital sector, municipal sector, industrial sector, and particularly the industrial sillage. Okay, every industry will have a sillage. Okay, now you can always say under the Water Act, the sewage and trade effluent should not be mixed. That is how the rule also says. So whenever there is a sewage is generated in industry, you have to put up a sewage treatment plant, but don't aim only putting the sewage treatment plant. Put the sewage treatment plant, generate treated sewage, use it as a cooling tower makeup or other reuse recycle avenues, because it is least in terms of capital and recurring. And all these things are also given the, let us say, the CPHU manual. So if you look at a typical wastewater infrastructure, you will have something called civil. They are basically to meet the process needs. Electromechanical, actually to meet both process and operational needs. Okay. In civil, the operational need is fixed at one time. My dimensions are fixed. I don't have any way of modifying it. Whereas if we choose a wrong electromechanical, I would say including instrumentation, they are meant for controlling the process. Okay, you have to lay more emphasis on electromechanical and instrumentation. The conventional ETP STP is a project management, and there is some changing going on pre-engineered. So I'm just giving a comparison. What is the difference between a turnkey and a pre-engineered? Okay, so it's something like pre-treatment, feed pump, feed regulation, biochemical treatment, process control, solid liquid separation, sludge recirculation, electrical control. All these process steps are automated when we talk about pre-engineered package plant. So you just buy and forget about it, because the operation maintenance will be much easier. Now when we do the characterization, I'm just running through quickly. When you are dealing with an industry, this will be very, very important, because nowadays even Ministry of Environment and Forest, under environmental clearance, they are now laying more emphasis on post monitoring. That is, the post monitoring means how are you going to monitor? Okay. So when you are putting up a water or effluent infrastructure in an industry, how you can lay your hand in pollution prevention or waste reduction so that my running cost is controlled effectively. So how do we go about it? Have an understanding of industrial classification, when it started, what is the built up area, working area and open area, because mostly in an industry, the green belt is one of the critical requirement. The water required for the green belt should be met from the treated wastewater. Okay, that is the reason why we need this information. This is a checklist. Okay, then extent of population influx, how much people, permanent staff, etc. Because there is a norm. If I know number of people, the per capita norm for an industrial situation is 45 to 60 LPCD to meet your human sanitation and the canteen requirement. Whereas in a residential area, it is 135 to 150 liter per person per day. That means you can establish the design capacity. If you don't have actual monitoring data, you can use a professional judgment. For that reason only, this is important. And when we deal with an industry, is there a seasonal variation? Suppose you're stepping into a food processing industry, every season the load will be varying. So your treatment plant also should be modular in nature. Okay. For that purpose, this checklist will be helping. And we should also understand the way the industry understands the terminology. Like the industry, they say fresh water, filtered water, soft water, demin water, cooling water. You know, when you do an audit, all this terminology, what the industry uses, you should be familiar to do walkthrough, gather the information so that you can lay your hand on minimizing, conservation, promoting, reuse, recycle. Same way, wastewater quantity, you must also understand how the total quantity, how it is segregated. Broadly, it should be segregated sanitary wastewater, various inorganic stream, which we call blowdown and rejects, and drainage layout, and what is the wastewater characteristic. If you have a hold on this, it will be very easy for optimizing the treatment plant. And then we talk about what is the capacity you need, what is the type of technology, what is the O&M cost, and what is the compliance requirement, standard requirement. These are the checklist. Okay, in-house variations. Okay, for a hotel. So whether the laundry is inside or it is not, when we deal with a hotel or hospital. And environmental conditions of the location, then the risk. We are situated in an area where the competing water demand, public is making hue and cry. Understand the site condition. Then the pollution control experience of the industry, and maybe I can tell I have dealt with one industry. Already 5 consultants have given solution and 5 solutions are put up. I was a 6th consultant. I said I don't want to give any solution, okay, because you have already burnt your finger, and so idea is how to retrofit. So I don't want to give an add-on system. I want to tell you 5 people have given ways and means of cutting down, etc. That is how you have to look at it. Likewise, I'm not spending time on this. And let us look from the approach what I said, green, blue and gray. There is a water balance. You need to have a broad water balance. This water balance should look into segregation, primary, secondary treatment, compliance or certainly, nutrient is balanced or not, and advanced wastewater treatment plant is required or not. All that you should have a broad focus. Okay. And then if it is an existing industry, check whether the existing systems are adequate or not adequate. Okay. And conceptual issues, constructional issues, operation maintenance issues, you must have a hold in an existing plant. But with all this background, what is my objective? I have this entire water balance. You have to treat it. What do you want to do with the treated wastewater? So you must have some broad focus. How much portion will go for reuse, recycle? How much will go for residual matter for disposal? And if it is so, is there any restricted land application? And can I now talk about something? I cannot make everything. So then I need to think about recharge and others. Okay. Even you may think of supplying the treated wastewater to your neighborhood at a very low or no price. So when you look at your avenue of looking into reuse, recycle should broadly look into this framework. Now, when you look at an industry, you must also understand the industry. What are the core functions? Okay, in process, floating population, outsourced, low volume, high TDS stream, high volume, low TDS stream. Then how the utility department is having control over, because many times you have to understand whether treatment plant is managed by the contractor or utility department of the industry is managing it. It makes a lot of difference. That's why you look at support utility function, water treatment pump, boiler, power, air conditioning system, crate washing, canteen, laundry, all these put together. You need to have a broad understanding. Then it is always better arrive at specific water consumption. If you are talking about pulp and paper, the norm is saying 10 to 60 cubic meter per ton. That's all I can consume, not more than that. So you can now lay your understanding based on the broad water balance. Where am I? Is the per capita water consumption or a specific water consumption is in the requirement or not? And even the pollution control board gives the consent. You broadly segregate water priority, emission priority, solid waste priority, and generally this is what also revamping going on. Even the environment clearance, they give 120 condition. Same thing happens with the CTO, they also give 120 condition. In fact, I am fed up with the way our regulatory functions or our policy functions. When you look at the consent to operate, many of the conditions are to protect the decision makers' chair, not to protect the environment. So I used to give guidance to the industry. Please review all the conditions in terms of compliance nature. Please make an assortment. How many conditions are compliance in nature, and how many conditions are generic in nature, and how many conditions are policy driven, and there are conditions where I don't have to worry. Okay, I can say 60% of your conditions will be somewhere here. Okay, that is also equally important. So as I mentioned, your pre-treatment is all very important. So your treatment technology can go into suspended growth system, fixed growth system. The suspended growth systems are a lot of family, activated sludge process, SBR. I just wanted to tell today the wastewater treatment falls only into 3 families. Okay, the family 1 suspended growth, family 2 fixed growth, and family 3 is a hybrid growth. I can tell commercially today there are more than 150 jargons. Okay, SAFF is also a jargon. Okay, that is called submerged aerobic fixed fill process. It is just some of the technological player, they want to protect their technology, so use the jargon. You as a user are working in an academic institution, just don't go away by the jargons. Okay, understand that there are only 3 families of wastewater treatment: suspended growth, fixed growth, and hybrid growth. Okay, and if we go into CPHEO manual, that is Central Public Health Engineering and Environmental Organization, part of Ministry of Urban Development, I have consolidated. There are other technological processes going through, so this you can go through in the PowerPoint later. Okay, so what is the template? If you look at a wastewater treatment, the template should be something like this. It should have a pre-treatment process and site specific, and it could run something like screens, oil and grease, collection well, pumping, primary sedimentation, etc., biological treatment, tertiary treatment, specific treatment. This could be broad template. That means based on the wastewater flow and the characteristic, you must make a flow sheet. That flow sheet will be combination of these things, and also sequencing in when it should come, etc., will be part of your wastewater treatment. Say for instance, so this is a flow diagram. I'm talking about, okay, there's a raw effluent. First I need to go through bar screen, oil and grease trap, grid chamber. They're all part of treatment. Then I must talk about a balancing tank. Then you talk about primary clarifier if it is required. Normally we say primary clarifier is required if your suspended solid is more than 300 milligram per liter. Otherwise it will put more load on your biochemical treatment. Then we talk about aeration, the solid liquid separation to be removed, then it has to be recycled. Then I told you the wastewater treatment, the byproduct is the sludge, and sludge must be also handled, maybe an anaerobic digestion or a sludge drying bed or a mechanical sludge dewatering system, whatever. Okay, and the utility would be, it could be a blower, it could be a surface aerator, depending on what is the technology. It could be one, it's called activated sludge process. There could be another system called extended aeration. In the extended aeration, what happened? I have removed the primary clarifier. That's how it is. Okay. So you can see number of steps are minimized. The rest of the things are same. Okay. Only the primary clarifier is out. You can even talk about a system called suspended growth, but it is called hybrid growth, the sequential batch reactor. Now you see the primary clarifier and the secondary clarifier integral part of an aeration tank is one. Okay. So compared to the earlier, so the earlier you have an aeration tank clarifier, but now what I have removed the aeration tank and clarifier into one. That means it is an integrated. So it is cutting cost. Okay. Likewise, there could be a rotating biological contactor where I need a very good buffer tank. Then you have a rotating biological contactor and go with the lamellar separator, etc. These are all the sequence of putting various treatment process. Okay, so fundamental concept is what? Whether it is a hybrid, suspended or fixed film, let us understand a little bit on the concept. There is an effluent after the pre-treatment and primary treatment comes into an aeration tank because heart of your process, 70% of your capital, maybe 60 to 70% of your energy cost is actually hovering around these two steps only, aeration tank. So that is why you should understand the concept very well. So this is called aeration tank, then the biomass is separated and the biomass is recycled. That is how we call MLSS, mixed liquor suspended solids. That is active biofuel. So I am recirculating it. When it comes to a trickling filter, the concept that is this is called fixed film. Okay. Definitely you need a primary treatment very well because it's a natural process. I don't need any aeration. Okay. The trickling filter is basically you will find the treated wastewater is recirculated. Unlike in sludge, activated sludge process where the sludge is recirculated. Okay. The difference between sludge is recirculated in ASP, treated wastewater is recirculated back into trickling filter because trickling filter needs a low BOD. So I need to achieve dilution so that whatever organic stuck on the media, your natural aeration process is promoted effectively. That is how the trickling filter concept. But when we look at advanced wastewater treatment, something like membrane biological reactor, compared to a conventional, I'm talking about an apple to apple. I want to achieve a recycle grade norm. How conventional wastewater treatment and membrane biological reactor differs. So this is the first sequence. I talk about an influent, primary clarifier, nitrification, denitrification. Then it is called aeration tank. Then it's all return sludge recirculation through clarifier. Then I must have a gravity filter, ultra filter or a micron filter. Then you get a quality fit for recycle. Okay, membrane biological reactor nobody will put for disposal now. And there is an increasing demand going on in this process. That is why I'm laying my point here. So whereas in a membrane biological reactor, you will have same pre-treatment, etc. But most important, you need to necessarily have a very, very good pre-filter. You have must be removed. Then you have everything. All these things are eliminated. I am removing secondary clarifier, I'm removing gravity filter, I am removing membrane filter, everything I am removing. Then I am putting the membrane either inside or outside. So this is something membrane biological reactor, which we will talk a little later. So like earlier, the membrane is within the part of the aeration tank. There are membrane, I don't deal with frequent operation maintenance problems. So I dedicate the membrane separately. Okay, it's called airlift membrane biological reactor. So if any problem, I can attend. So my bioreactor is not disturbed, something like that. So all the chemical cleaning is also required, whether it is in situ or ex situ. Okay, so based on this, the technological process also have undergone change. And this is called submerged, we call sequential batch reactor, or we call IDEA or a CTEC, different technological name, but understand the process. What is happening? The entire process is happening in the same tank. So it will operate first on feeding, okay? Allow the aeration, after aeration, allow the sludge to settle, then you decant it. After decanting, again the cycle goes on. So it is called cyclic process. But then there will be battery of 2 or 3 tanks What is so important here? This can be a batch process, it can be a continuous process depending on the capacity. Okay, and invariably for large plant it is a continuous process. That means I will have minimum 3 tanks. One tank is operating feeding and aeration, etc. Second tank is operating on the decantation mode. Third tank is now ready for. So that is the kind of, that means everything is program logic controlled. Okay. So that means I am feeding the wastewater up to a predetermined depth. I will decant it. Okay, normally the differential depth of top water to the decanting depth will be about 1 to 1.2 meter only, not more than that. But the depth of the aeration tank will be about 6 meter. Okay, 6 minus 1.2 balance. That means your oxygen, you just imagine the oxygen requirement is 40% saved. Because when you are feeding, I don't need to aerate it. When you are decanting, I don't need to do. When you are settling, I don't need to supply. So that means only when you feed and aerate, I need to operate your blower. Okay. So initial energy, that is your the starting current will be more, but the net recurring cost I am minimizing to the extent of 40%. That is how the technology has come into the place, and mostly it is applied for only reuse recycle grade. Okay, now we come back to the fundamental, how the technological role plays. So I go back how the cost cutting measures. Okay, now when you look at heart of the process, please understand there is something called volume of the aeration tank. How do you arrive at the volume of the aeration tank? This is nothing but there is a flow, there is a BOD in and BOD out, how much you want. Since you give this in milligram per liter, I am converting. Milligram per liter is gram per cubic. I convert to kg per cubic. That is how 10 into minus 3. Whatever unit I have given, please use the flow data in meter cube per day. Use your BOD, COD in milligram per liter only. But what you get on the numerator will be BOD load in kg per day. Divided by, there is something called food to microorganism, and then there is an MLSS. What is food to microorganism? I will explain further here. Food is nothing but the numerator. Okay, food is nothing but the numerator, and now that is food is nothing but the organic load. Okay, and what is M? That is the inventory of the biomass in the aeration tank. So now this is technology developer is fixing the F by M. Okay, F by M is not fixed by the technology provider. So normally we say conventional activated sludge process will be about 1.8 to 2. When you go into extended aeration, then F by M ratio will come down. Okay, and this is the desired MLSS, what you want to maintain. So you apply units and dimension, I get the volume of aeration tank. Okay, so more detail you can go into the CPHU manual. But fundamental concept, you must have a hold on this. Okay, so what is F by M ratio? Again, I want to explain. Okay, the explanation is food to microorganisms. Suppose the ratio is small or the ratio is high, just a physical understanding. If the ratio is high, means food is abundant, microorganisms are less. What will happen? Still enough food, so there is no competition for the microorganism to start eating. Okay, that means it is lazy. The food is available, so there is no competition. The process will be inefficient. But if the food is very, very low and the microorganisms are very high, what does that mean? There is a competition, starvation. So I can even say there will be cannibalism. That means the microorganisms themselves will eat the other less competing microorganism. In fact, in an extended aeration and highly extended aeration process, the net sludge production comes very, very low because of low F by M ratio, what the designer is choosing. I can even eliminate the extensive sludge dewatering. So that is the concept you must understand. Now with this, I go into 4 cases of cost cutting. Okay. The first one is conventional system where aeration tank, clarifier, return sludge pump, everything prevails. Okay, there is no compromise. Everything will be there. So in that you can always go. This could be varying. Okay, what are the MLSs? What is the F by M ratio? And you don't have to. Now you can understand lower the F by M ratio, higher is my efficiency. So MBR will operate 0.1 to 0.155, but the efficiency is greater than 99.99. Highly extended aeration process also. So you can say F by M ratio is an indication. Lower the F by M ratio, higher is my efficiency and lower is my sludge production. But energy also will be more. Okay, you have to consume relatively more. Okay, so go to the concept. Numerator indicates the extent of incoming BOD load and extent to be removed. F by R is the designer. Food is F is the food, which is nothing but the numerator, and M is nothing but biomass inventory. That is aeration time volume into biomass concentration. Lower the F by M ratio, etc. Okay, now I'm just coming. What is surface air? This is surface aerator can give the oxygen, diffused aeration can give you the oxygen, or a spiral aerator can give you the aeration. So that is all. I'm not going into the detail. How do you meet your requirement? I'm in a meeting, yeah. Okay. So the typical parameter I skip, but understand how the oxygen requirement. So if the F by M ratio is more than 0.2, I need less oxygen. That is 0.9 to 1.2. If my F by M ratio is going low, sometimes the requirement, if it is less than 0.1, for every kg of BOD removed, I have to apply 2 kg of oxygen. This is the computation, and the understanding of oxygen requirement is, please understand. So oxygen requirement is linked, 1 minute. Sorry, okay. So let's say the microorganisms are dying, okay. The dead microbe will take 1.42 kg of oxygen for every kg of biomass destroyed. And if I have an organic nitrogen, every kg of nitrogen will demand 4.54 kg of oxygen. So that is how the logic of the oxygen requirement going up. I am in a meeting, please. Okay, I will call you later. Okay, so this just to give an idea, the air required in case of diffused aeration, whatever you computed earlier, I'm just converting. Okay, whatever way you computed, then you come back. If it is a diffused aeration, so many kg per hour convert to grams per hour. X grams of oxygen per cubic meter of air per meter of liquid depth. Okay, and what is X? That is the efficiency of your diffuser. Okay, if it is a coarse bubble, it is 3 to 4, medium bubble 6 to 8, and it is a fine bubble 10 to 15. That means my amount of air required is linked with the configuration of the diffuser. Okay, if I want to save energy, necessarily you have to go for fine bubble diffuser. Same time, if you want to tap your energy efficiency, my liquid depth of the aeration tank should be minimum 3.75 meter. If you go lower than that, compared to a surface aeration, your diffused aeration will not give that much energy efficiency, which is also very important. Of course, now surface aerator is already out of market because energy efficiency comes into the market. So nowadays, the surface aerator is used only for mixing purpose, not for the biological treatment purpose. In the case of trickling filter, I have already mentioned the treated wastewater only is taking to the influent, and then the process is going with hydraulic loading, organic loading, what are the depth, what should be the recirculation, what are the power requirement. If I look at compared to suspended and hybrid system, the trickling filter is the lowest in terms of operation maintenance, but nobody picks up. Why? Because no turnkey supplier is interested and no municipality is interested. But if you are really an environmentally genuine, you should promote trickling filter, because today the business is driven by the market. And in the market means the player are not interested how I can supply more equipment, not civil work also they don't want to spend time. That is how the market for trickling filter almost gone. Okay, the hybrid system is mixed membrane biological reactor, the sequential batch reactor, moving bed biological reactor, etc. Okay, and of course, when I want to talk about a typical rotating biological contactor, I just go through, this is a packaged sewage treatment plant. I just run through how this is done. Now, in this case, a pre-treatment, it is a 600 KLD plant. So you have put totally an automatic operated, let us say, screening system. So this is actually a wedge wire system, and it is removing, and then you operates on a level sensor, and this discharges compressed one, so there will not be any fly nuisance, etc. Easily manageable for disposal. And the entire RBC is actually assembled at site to cut the cost. So you do the assembly, and once assembly is done, then you look at the system. Then it is some concept. I'm talking about even the aeration tank. You look at the way the diffusers are put, because the aeration tank with a very high BOD smell, it will definitely cause smell. So it should be pre-aerated. Okay. Here the concept is, make the ring main system so that every diffuser is giving uniform quantity of air, so that mixing is uniform. Okay. Okay, now this entire drive is actually overload relay protected, the cumulative hourly meter reading, everything is automated. Okay, that's the kind of technology, and it's operating in Bangalore for 600 KLD plant. What is more important, this entire treated wastewater is used for toilet flushing, and also some surplus going for their own gardening, and some other vegetables are grown because it has to be disinfected and then used for those purposes. Okay. Okay. There are also possible solar operated package treatment plant, which was done in Delhi for education institution, and ran for 6 months under a joint venture between IIT, Guru Gobind Singh University, and I was involved as a technology supplier. Okay, it's an Indo-German bilateral project. So today these kinds of concepts are coming up, and how to assess performance of an effluent treatment plant. I just give one example of a tannery. Okay, so if you want to do a performance evaluation, you must go through all the unit process operation and decide where to collect the sample. In this case, every wastewater coming and receiving in an underground sump, decide about 8-hour composite every 30 minutes and do the parameter selection. Then inlet to equalization, outlet of equalization. Then you talk about clariflocculator outlet, which is inlet of aeration tank, secondary clarifier outlet, tertiary clarifier outlet, then sludge, how you manage, etc. And then in this case, the entire energy is also monitored, because the energy is supplied by an external, that is SWAT board, that is a electricity authority. You cannot tamper that. So I can always read the dedicated energy meter reading and look into energy consumption is going correctly. So nighttime I can switch off some of the blower. So I can make out this is part of your performance evaluation. I'm just giving an indication what is the outcome of that. So we have something, you can make a template like this. There is a process, what is the dimension, what is the allowable value, and what is the actual value, and give your performance indicator, what is the problem here. Okay. So now the screen, basically originally some 3 to 6 mm mechanical screen was put, but then they have replaced that and went with 10 mm screen. But then vertical automatic step screen, what was put up due to maintenance reason, they taken out. Because of that, your primary clarifier or a coagulation fluctuation tank is taking more load. Equalization tank, there is something called criteria. Your mixing energy should be more than 15 watt per cubic meter, but when we checked, it was 28 to 30 meter. That means it is more than the requirement. Submerged mixer, but is it running 24 hours? When we checked with the energy consumption reading during night time, this was put off. That means if you put off, everything will accumulate in the equalization tank. So that is the kind of problem you will face. Likewise, primary clarifier, you go with aeration tank. So you will find the aeration volume is very good, but what is important is your aeration DO is nil. That means it is overloaded. Likewise, secondary clarifier, all this performance evaluation you do, come to a conclusion. What is the conclusion? Non-utilization of rotary screen, poor quality of diffuser because they were making every 3 months change of the diffuser. That means the running cost. That means when we inspected why it is replacing every 3 months, they sourced this diffuser is nothing but the old cycle tube. Okay, people are masterminded how to convert. You know, they say laser guided, but it was not laser guided. And the absence of chemical preparation tank, etc. So some of the idea how you can look into the performance evaluation. So the idea of telling all this example is, wastewater can be treated, but is it treated to the required purpose? So you need to think differently, okay? So arrive at capital cost, energy cost, chemical cost, and also the parts replacement costs, okay? And what is the hidden cost and degree of skill required for various treatment technology. So that means you have to really look at how the capital cost, running cost is evaluated. Do not carried away by various abbreviated technologies like activated sludge process, sequential batch reactor, membrane biological reactor, cyclic activated sludge, C-Tech, membrane moving bed biological reactor, etc. As they are more for marketing jargons, but be familiar about technological requirements like I mentioned, oxygen requirement, aeration adequacy, civil tank adequacy, electromechanical adequacy, etc. Okay, I can proudly say there is something called C-Tech. Okay, when this JNN URM concept was promoted in this country, 3 states they have masterminded in this technology. More than 130 sewage treatment plant established under the C-Tech. And I was surprised. One of the problem right in the place where I'm living in Coimbatore, the sewage treatment was put up in a very close residential area, and under the town planning, the sewage treatment plant cannot be located in that location. Then the Residential Welfare Association approached the court and they took an injunction that this e-tech technology don't implement right now. So then I could get a lot of idea what is happening. Okay, this is one technology promoted. The technology prescription in the tender is only one. That is very clearly mentioned, C-Tech technology. Nobody, no bidder is required to bid other than this. Okay. And when I review the tender says the treated sewage should be used only for reuse recycle. Mention very interestingly for toilet flushing, for something like cooling tower, etc. Can you imagine in a municipal corporation how can you talk about toilet flushing when the sewage is coming from battery of distributed way, unless you lay a parallel treated sewage line, and that should be supplied to every household. You know, it is unimaginable. Okay, but I can tell you when the country like USA, particularly California, had undergone severe water crisis, the California local body have gone ahead with a dual system. They call sewage is treated, and the treated sewage is actually supplied through another pipeline system meant for similar application. Okay, concept they have drawn from there, but unfortunately the plant when they put up in the tender, they have not prescribed the laying of first holding the treated sewage and laying a parallel line, distributing to various local body, etc. was missing. So some of the cost, that means you can imagine this is a technology promoted out of benefiting the municipal corporation. You can imagine, I always say within inverted comma, it is people are interested in technology, not interested in running cost. Okay, they can always play this dirty role of no, this technology was implemented because the lowest maintenance cost. Okay, you can see this in Mumbai, you can see this. In fact, only in 3 states this was implemented: Gujarat, Maharashtra, and Tamil Nadu, nowhere else. Okay. So, but I have made a big impact, and it went into the National Green Tribunal. That project was put on stalling, and this entire thing was questioned, and now of course this has undergone a lot of change. Then the execution strategies, conventional project management style or product management style. So which I mentioned, if the capacity of the plant is less than 1 MLD, there is always a possibility of going with the product system, not the project system. And STP, ETP, whenever you are putting, is it for regulatory driven or it is for ownership driven? What is the meaning of ownership driven? That is where the regulatory authority should always look at it. So make the sewage treatment plant is giving the treated sewage meant for replacing the freshwater requirement for cooling tower requirement or the landscaping requirement. So you should always put a meter and secure nothing is disposed. Then you will find there is a ownership is coming, because now I am running the plant because your water requirement is met. Again, it is driven by the cost of water. Now also integrate rainwater harvesting or treated water harvesting. So what is the difference? Rainwater harvesting, you can think only whenever it rains, which is very, very sporadic. Except some location, maybe it may rain for 3 months at a stretch, like very maybe even not continuous downpour. But you can very well say in a year, maybe 2 to 3 months, and within that maybe some sporadic rainfall or it is an intensive rainfall. Whereas treated water harvesting means I can promote all through the year, okay? But this concept is never integrated in our water management, okay? The same rainwater harvesting structure, you can use it in promoting treated water harvesting structure. It is nothing but aquifer recharge. But you have to be very, very careful. Aquifer recharge to be practiced only when the heavy metal or any other thing is absolutely not there. You'll have to make sure the treated wastewater, at least for treated sewage, no issue. But if you're talking for a trade effluent, make sure the residual heavy metal, residual organic, inorganic, etc. is conforming to the requirement. So it is nothing but mimicking miniaturized hydrogeological cycle within your own premises. That is how we integrate green, blue and gray. Okay. Look around you for pressing competitive environment. What is the competing water users around you? What do the community needs in the setting around you? What are the social problems? Non-availability of quality water, and what is the price of available water. Now when you look at, please look at your infrastructure in this perspective rather than looking only the other water management. Okay. So I always say source and sink is the same, but time and space decides the fate of the environment. So this is how you understand. So every city has got a waterway. Okay, every city has got a waterway. So I stayed in Chennai. There is a river called Adayar, which is now it is called Kuvam. Okay, so you all must be knowing there was a film also shot. Okay, before independence, people used to draw water from that river. Okay, and used to have even the boat ride, etc. Okay. But now maybe 7 decades gone. So after 7 decades, what you see is the sink is completely polluted. That is how I am telling time and space decides the fate of the environment. Every city has got a waterways. It is time that our waterways are rejuvenated. How do you rejuvenate is something which I handle in the first session, land intensive treatment, and in this session I've handled with the technology oriented wastewater treatment. Okay, it is a combination which you'll have to think about in preserving your hydrosphere. Okay, I care definitely. I'm sure most of you present in this forum, you also care. But somebody from this, a voluntary entrepreneur or a voluntary teacher or an academician, need to set a path breaking. I always tell, even every educational setting is like a mini municipality. So whatever problem you face in the municipality, you do face in your institutional setting. Crime will be there, There could be, water issue, there could be effluent issue, there could be solid waste issue. Whatever municipality is facing, you are also facing in the campus. So it is time that how do we make the campus also green? So you can green your campus. Look at every problem. Is it what energy audit done, water audit done, solid waste audit done? You can start doing this as a project. You can institutionalize a project for your own students. Okay. So that is how I look at, water management, looking into source, characterization, treatment, reuse, recycle. And the last one I said, decentralized way of looking at our water management. So when I say decentralized water management, I would say hotels, education institutions, hospitals. Everybody has got their own resource. Okay, they are also spending money, but you have to cross-examine. Are you spending the money wisely and also improving the institutional setting for a different environmental improvement? So there is also another way of looking at it. I did this exercise for IIT Chennai. Okay, IIT Chennai had during my, because I also studied in Anna University, and IIT and Anna University are in the proximity. So in 80s, there used to be a very high level of water scarcity. Okay, then the IIT campus did a project called how do we meet the students' toilet flushing requirement and the landscaping requirement by treating the sewage. Okay, and first time the IIT campus established a treatment plant during that period of very difficult pathway of water scarcity. They institutionalized. Of course, now if you look at it, they're all gone. Okay, but they have to refurbish it. The problem is, you create a pond, and the external municipality is able to supply water. Then all your in-house capabilities are not put into restoration. So that's also another way of looking at it. Why I'm saying this, every campus is an ideal situation for promoting, water management, energy management, solid waste management. It also reminds me that solar panel, what I was making a brief presentation. The idea of the project was something to institutionalize in Guru Gobind Singh University, which was earlier name is Delhi College of Engineering, which is now named it differently. So this was an Indo-German bilateral project. IIT Delhi was evaluation institution, and Delhi Jal Board was the agency, provided the space for putting this package plant. And we wanted to set up the plant in the campus, but unfortunately the campus was not ready. And so we have to put a plant close to the existing sewage treatment plant of Delhi Jal Board. And we tapped 50 KLD out of it because our intention was one of the girls' hostel, the requirement of flushing water should be met through this package treatment plant. So the results were available and it was meeting the norm, whatever I was mentioning, the toilet flushing norm, because it should be nitrification, denitrification mode. It was all rendering, but then what happened, and also solar operated. So my net energy requirement also was very low. And this was a technological demonstration, but institutionalizing that will take a lot of time. But that is how you have to look at it. It's all possible. Okay. So another concept also was taken up, and another project. What I am telling, the project is if I take 25,000 population equivalent. Okay. So 25,000 population equivalent. Now you can look at a decentralized water management, sewage management and garbage management. So these three things were integrated. Okay. So how it can be integrated? You can say under solid waste management rule, dry waste, wet waste and domestic hazardous waste must be segregated. Okay. It is now going through the process. So what we said, you establish a sewage treatment plant catering to 25,000 population. So 25,000 population multiply by 150, you will get kind of wastewater roughly about 3,750 KLD. Say I'm aiming say 3 KLD. Okay, no 3 MLD. Okay, so 3 MLD wastewater. Now I don't want the municipality to talk about underground sewer work, etc. Because these wastewater you can naturally available. Make sure they're all collected, brought into a terminal collection tank, put the sewage treatment plant. So I treat the sewage. The treatment plant will give you the sludge, correct? Now the same 25,000 population, even if you take about 100 gram per person into 25,000 people, that means 2,500 kg per day of wet garbage will be generated. Now the wet garbage I want to produce methanation, biomethanation. Okay. Now mostly biomethanation, when you talk about only for wet garbage, there is a nutrient imbalance. It may not have the required nitrogen and phosphorus. So now the concept was thought about the treated sewage, the treatment plant will give a slurry. Okay. Now don't go for a mechanized way of talking sludge driving bed or a belt filter press or a dewatering system, etc. No. The wet garbage also need a slurry. So now what you do, make your wet garbage, slurry is available, make these two things, go through a biomethanation. So now you produce energy, you treat the sewage, treated sewage will be now aimed for promoting reuse recycle. So that means energy efficiency, the biogas production and sanitation improvement and treated wastewater available for secondary reuse recycle. So you can think about 4 broad components of environment was addressed in such project. Okay, so these are some of the ways how you look at a decentralized thing. In fact, this project was put up to Department of Science and Technology. Almost it was cleared, but I don't know what was the problem. Maybe there are, so no, this is an area where who are the members present in the we have that sometimes the members themselves will have a vested interest. So when it comes to the decision making is taken not on the technological competitiveness and the long-term strategy. It goes with a different decision process. Okay, this is a sorry state of affair. But idea of sharing this information is you can even think when IIT Delhi was very much interested. Even with IIT, the project could, Environmental Research Committee, what we call, they could not succeed. So you can imagine what is the kind of systems goes in the Environmental Research Committee. But idea is most important. Okay. So with this, I'm closing my session and looking more towards the question answer, because I kept my session for 1 hour and 30 minutes for question answer.
I would encourage the participants to please come forth and ask any questions or doubts if you have. You can even type in the chat box.
Yeah, correct. So there are only 28 participants.
Yes, sir. So earlier case we were all in lockdown condition, because of which we had significant number of participants. This time, sir, everything is open, and
Okay.
because of which everybody has got busy into their everyday lives.
Okay.
So the participants, please come forward and ask any questions or doubts. It will be nice if you discuss any of the concepts. We have some participants from the South India as well, sir.
Let's see. Acha, this is the open to everybody, huh?
Yes, sir.
Okay. I'm just looking whether there is any familiar face. Should be there. Manjunath is a guest. And he is on hold. Maybe you want to raise. Okay. Yeah, I hope, last time it was a land intensive and this time combination of package treatment system and the clarity of, dividing the entire treatment plant into large, medium, small and tiny. I think that concept is very, very important when you are talking about water management. I can tell even the Delhi Jal Board now has come out for the peri-urban area. Peri-urban area, still the underground sewerage network is not established. Okay, so there the project is something like it is going. In fact, one of the DPR I have reviewed and given a lot of criticism on that. So they went with the concept of putting maybe 10 small package treatment plant like zero point 0.5 MLD, zero point 0.2 MLD, 2 MLD. Okay, and the concept is everything put together. One agency will implement. What is that? One is laying the underground sewerage network, bringing that entire sewage into one battery, where in the battery establish the sewage treatment plant, and the treated sewage should be looked for rejuvenation of water body, and surplus water available should be used for green belt development or disposed into natural course so that your aquifer recharge is taking on its way. The concept was very good, but then the way in which they put the treated quality, they put the treated BOD less than 3, which is as good as river. So why do you need that kind of a quality? So and then they made a mistake saying that if I create such infrastructure where I'm going with one agency, they have not even fixed the wind-up contract for 10 or 15 years because you have to bind them. So if you don't promote on a PPP model, that is public-private partnership project, you will create a non-performing asset. So what will happen? What is the burden? After all, this is created. Again, it comes back to you. But when you are putting such a decent peri-urban water infrastructure project, you spend time very well on, this is an area where the Australian government has come out very well. Uh, where I happen to study there, it is called the Public Works Department. And they masterminded this PPP model. Okay, it could be a build one, operate, transfer, or build, finance, operate, and transfer. This kind of a model. These kinds of concept very much talked on the revenue model like water treatment plant, but slowly it is coming up in the sewage treatment. So in this case, I was mentioning about this should be rooted through binding the contractor on a long-term running. Otherwise, you put a plant where the supplier, all the hardware, whatever supplied, it will conk within 18 months because that's the guarantee the supplier will give. So after 18 months, you know the situation. Suppose you bind them on long-term operation maintenance, they'll be very, very careful in choosing the hardware because my money making is in the O&M contract of 15 years, not in the beginning. Okay, so this concept, like you have the highways, National Highway Authority promote this project of building the roadways on PPP model. Okay, so that is successful. Now you have a toll tax, etc. Something of that type must be built in. Otherwise, all this water infrastructure, non-performing assets only you create.
But sometimes I wonder how the people outside India treat water to such a level that it can be reused. In fact, if they can even drink that water. So how they might have done that?
No, no, these are all, see, one is it is a societal driven and the pricing policy of the water. So today we talk about zero liquid discharge, but my cost of water, just imagine, cost of water is lower than the treated wastewater. The recycle will never make a business sense. So you have to always make, there is a needy, for them the water should be provided. That is only the public. You don't have to price the water for commercial and industrial low. Okay, so there has to be something like at time, even the public, you have to think about pricing the water. Otherwise, what happen? Your pollution will not be controlled. That's what happening. So today, if you talk about wastewater treatment for commercial and industrial, 30 years we are matured. At least people have an infrastructure, and many of the infrastructures are operated. Maybe some are not operated. But if you talk about infrastructure is there, yes, it is there for the industry. But if you talk about for sewage, do you have an infrastructure? Yes, it's only for 20 to 30% of the sewage, that too only in large metropolitan cities. You don't have anything for class 1, you don't have anything for class 2. Even cities like the city like class A cities, it is not that entire sewage is treated, maybe certain percentage only is treated. So now this is a misplaced resource. So in the long run, I think the treated sewage will be available for industrial purpose, which is very much there in Chennai. Okay, the entire Manali belt is getting their water through treated sewage only. So likewise, it will come up. We have to be prepared that. And I am talking from campus point of view. At least I have spent quite a lot of time how the campus can meet their water, because you may draw water from borewell, but then you don't rejuvenate, because whatever water treated, you may treat and dispose, but not organized way. So your water is getting dropped. So this also miniaturized hydrogeological cycle. You have to set it right in the campus also. I think not question, something is.
Sir, we have a compliment from Balendu, sir. He has said that it was a very nice and informative session, sir. Thank you.
Okay, I think people are shy to raise question, looks like. Or anyway, if they have any other question, I think I have given my mail ID lbkkutti@gmail.com. So people want to raise question, you can send mail to me only with a mention in the subject about this institution name, so that I know there is a reference, otherwise I may delete it. Okay. So madam,
Thank
from
you,
your
sir.
side also no question. So thank you very much.
Thank you so much, sir, for taking out time from your schedule and enlightening us. We hope to see you in person sometime in future, sir. Thank you, sir.
Okay. Thank you. Bye-bye.
Yes. So with this, we end the second session for today, and we will be meeting again after the lunch break for the third session at 2 p.m. So I hope to see you all. University Taiwan from the and also at China, which was sponsored by DST Government of India. He has been awarded special fellowships, which was a scheme for promotion of academic and research collaboration at the Hanyang University, Seoul, South Korea. He was also awarded International Travel Support Grant from DST for presenting at the international conference at Kunming, China. He was also awarded third prize at a program from the CSIR, Ministry of Science and Technology, that was supported by IIM Bangalore. He has been working in collaborations with Sejong and Hanyang University, South Korea, CSIR NIST, Kerela, University of Hawaii at Manoa, USA, Indian Institute of Technology, Banaras Hindu University, Varanasi, CSIR IITR Lucknow, UP, and Indian Institute of Technology, Guwahati, Assam. I welcome you, sir, on behalf of the Civil Engineering Department of IPS Academy. We are highly honored and privileged to have you with us, and I thank you personally for accepting our request. And I request you to please start with the session, sir. Sir, your mic is muted, sir.
Okay. So first of all, thank you, ma'am, for a nice introduction and a kind invitation for the presentation of 1 week online short-term training program on water quality, complications, restoration, and environmental conservation of, of existing water bodies. I will go to present, ma'am, the sound is echoing. So can you mute your side?
Yes, sir.
Ma'am, is it my slide visible?
Yes, sir.
Okay. So today I'm going to present on the hybrid treatment system for the remediation of volatile organic sulphurous compounds and dye containing wastewater effluent from the industrial as well as drinking water. So, as we know, nowadays the rampant industrialization and unchecked growth of the modern textile industries and their production for the various products like dyes, color, volatile organic compounds, odorants, and other hazardous materials. They create their effluent create the toxic and harmful impact, including the carcinogenic effects on the water and uh, any water bodies, and they create the pollution. So therefore, the development of cost-effective and efficient control measures against such pollution is imperative to safeguard ecosystem and the natural resources. For this, there is a trend for working on the biochar. As India is a huge sources of the uh, agro vegetation and forest vegetation. So now people are using this vegetation for the production of biochar, which has a very special capacity for the absorption of the pollutants. So in this presentation, I'm going to use the application of biochar for the treatment of volatile organic compounds like hydrogen sulfide and production of biogas enhancement. And also, I will take care of the degradation and removal of dye from the wastewater. So the unbuilt industrialization and unrestrained expansion of the modern textile facilities, combined with deficiency of adequate treatment provisions, have escalated the discharge of toxic effluents, which cause the carcinogenic effect in the river water system or any water system. And biochar has propelled itself to the forefront of the scientific community as a highly economic solvent with great absorption capacity, and it is very cost effective. When we use the biochar for the treatment of any wastewater, it is very cost effective. As we have worked at IIT BHU, and we found it is more costly than the any other technology. And if we have done the study using the several kind of dye, including Congo red, malachite green, and the end applications of agrochemicals like some pesticides, atrazine, and some sulfur containing and phosphorus containing insecticides was also treated by the biochar using some hybrid bioreactor system. So here this slide show the textile industries in the India. So as we know, India is like a very huge country with a very more than like 135 crore population, and it's a very demand of the any product. Like so, the size of the textile industries in India stood at 150 billion US dollar as of the 2017. And textile industry in India is one of the largest in the world with a large raw material based and manufacturing strength. It shows like with 3,400 textile mills having installed capacity of more than 50 million spindles and 8 lakh 2,000 rotors is the second largest in the world. Textile industry contributes around 7% of industry output in value terms, 2% of India's GDP, and to 15% of the country's export earning. With over 45 million people employed directly, the textile industry is one of the largest sources of employment generation in the country. This chart is showing the textile and apparel industries in India. So now there is a question that people may ask, why should we not close these industries because of their pollutant emissions and the secretion which destroy the polluted the river water. So by seeing this advantages of this industry, as like 45 million people are employed directly and indirectly with this industry. So and it contributes the India's GDP enhancement. So it is not possible to close, but we can use and we can apply some treatment system to minimize the pollution emitted from the textile industries are presented in India or anywhere. And this slide showing the textile industries throughout the India, and it's showing on the basis of the raw material like cotton, jute, silk, coconut coir, viscose, polyester, nylon, acrylic, polypropylene, carbon fiber, glass fiber. These are the like type of fabrics which presented throughout the country, and in different region it is like a different kind of material. Like in Jammu Kashmir, it's showing silk is more producible. So throughout the country, we have textile industry through India as per the type of biomass. And this chart is showing like classification of industrially important dyes on the basis of origin. So dyes are mainly two types, one is synthetic and the natural. Synthetic dyes contributes two types like azo dyes, which contains some nitrogenous groups, and non-azo dyes. And azo dyes are mainly acidic, basic, direct, disperse, reactive, sulfur, wet, and the others. When we go for the like name, so the acidic dye has an example Congo red, basic dye is one methylene blue. So we have worked with Congo red, methylene blue, and the reactive orange, and one sulfur containing dye, and wet blue dye. And natural dye is from they obtain from the animals and the plant. So the one dye, tyrant purple, is obtained from the animals, and plant gives the indigo dye, which generally the blue color dye. So one report has been published in the Ahmedabad, the best industry, which name is Meghmari Group of the dye production, and it's showing like how important is. So generally this graph is showing like basic dyes represented around 10,000, sulfur containing dye is also 10,000, direct dye 20,000, acidic dye like Congo red, it's like 30,000. Others dyes which participate like 20,000 ton per annum, and reactive dye like 1 lakh ton per annum. So the Indian dye and dye stuff industry is an important aspect of the Indian chemical industry that significantly contributes to the latter's growth. According to a recent survey, the Indian dye market is poised to generate a revenue of rupees 48,000 crores by 2022. And these are the benefit of the dyes. So due to the availability of the necessary raw material and the regional hegemony of the Gujarat and Maharashtra over the textile industry, nearly 90% of dye stuff produced occurs there. Because of so many industries presented and available established in the Maharashtra and Gujarat, it is participated around 90% of the dye stuff production. During the application process, many industries release toxic agrochemicals and dyes in the aquatic environment and on the land without the proper treatment. Due to their toxicity, the disposal of such chemicals is of utmost importance. Biochar offers the ability to remediate these substances from environmental matrices because of their high sorption ability of pollutant from water and soil. So literature survey shows that most of the researches on biochar application have been concluded in the batch mode. Hence, there is an urgent need to apply this beneficial technique for the remediation of pollutant at the larger scale in the real water and the soil sample. We work generally in the lab, but when we go for the real challenge, like in like lab to land, so there are so many rules and regulations, and we are somewhere bound to not do, because like when we go for the large scale,
I think there was some connection issue probably. So we hope that Balendu will be joining again.
hello,
Yes, sir.
uh, yes,
So there was some connection problem.
yes, ma'am. Actually, in our place, it's a
Yes,
huge
sir.
problem.
There
Yes.
is connectivity issue, sir.
Yes, and only one thing, man. Actually, Guwahati, it's like 4 a.m. It's like dark, so this thing also like caused the problem. Yeah. So now that's
Sir,
why
please
the
share your screen, sir. I think your screen got unshared, sir.
ma'am, it is visible.
Yes, sir. Yes, sir. Now it's visible, sir.
Okay. So hence, there is an urgent need to apply this beneficial technique for the remediation of pollutant at the larger scale in the real water and soil sample. So I was telling like why these techniques are not going on the bigger scale, because it requires some government subsidies, some major funding, so that it can establish at the pilot scale level, which is the lacking between the researchers and the government side. And but the cost analysis of the various techniques where biochar has been used as an adsorbent is very important. And this is this slide showing the major methodologies for the remediation of dyes. So generally, the remediation of dyes containing mainly two types, physicochemical and biological. So physicochemical methods are involved like oxidation, adsorption. Adsorption contains the biochar and the membrane separation, ion exchange, and coagulation method, while biological methods contain like typical microbial degradation, direct usage of the enzymes as a biocatalyst, microbial fuel cells. So when we go for the like direct use of enzymes, there are so many industries which produce the biocatalyst enzyme, and when they use these enzymes in the any polluted river, lake, or soil, it works very effectively and clean the water within the 5 to 10 minutes. And the microbial fuel cell is one of the bioreactor which contains the like two two component, two compartment in which one is having uh, wastewater, and they have some microbes which work as a they use this wastewater as their nutrient source, and they break this pollutant in the enough in the simpler form in like a CO2 and H2O, and they use this as energy, and they produce power also. So this is a very important techniques now people are developing, like a country like China and South Korea and Taiwan. People are developed this thing, and in India they are also working on various aspects to enhance the microbial fuel cells techniques. Microbial fuel cells contribute the uh, pollution pollution minimization and production of power also. So, and here is some a biocatalyst name and their sources, and showing like how they work and what is the pollutant like dye or and the dye concentration. So I'm just giving one example, like there is one a biocatalyst named periphyton, and this dye obtained from the plant rock and the sediments, and this it work as a mechanism is like periphyton bioreactor, and the dye name was amaranthus dye, and it treated around 550 to 500 milligram per liter at the 30 degrees centigrade optimum temperature at the pH 7, and the mode was the like bioreactor, and it published by Saveretal in 2007. This dye like leakage biocatalyst enzyme is very important. Even in our lab here also, people are working on the leakage enzyme using the treatment methods for various aspects. So one Osama et al. Has worked with leakage biocatalyst using the Tremits pulses, obtained the this leakage dye and the alumina pellets. They have fixed this enzyme, and the reactive black 5 dye they have treated around 0.5 gram per liter at the range of 60 to 70 degrees centigrade temperature. This work we have published in Bioresource Technology in 2019. And yes, this graph is showing like how and why the biochar study is important. Uh, so as we can see, this is the data from the whole scientific record around for like 10 years publication, and it's showing like how the biochar data is and its application for the removal of only agrochemical, not even other only agrochemicals. So they have published around 7,000 publications for the treatment of agrochemicals using biochar within the 10 years. And the dye, when we use the dye removal, so this is showing around 18,000 publications they have published for the removal of dye using various kinds of biochar and its application. This slide showing like how the biochar prepared. So the biochar has several kind of waste biomasses which comes under the agricultural residue, invasive weeds, woods, animal manures, biomass deposited in the lake sediments, and all these biomasses can use in the one method it's called pyrolysis. Pyrolysis is the method which use around the heat in the range of 300 to 800, 900 or more than this in the absence of oxygen, in a pyrolysis system. The unit is called a pyrolyzer. In this unit, all the things happens. And when the biochar prepared, it is applied as a removal of agrochemicals, antibiotics, pharmaceuticals, pesticides, organic pollutants containing volatile organic sulfur compounds, which found mainly these compounds are found in the anaerobic digestion. When we go for any anaerobic digestion process, there is one hydrogen sulfide production in a very limited amount, but it causes the less production of the anaerobic digestion, where the biogas production suddenly decreases. So I have worked in the University of Hawaii on this aspect. So this is the showing like the how the biochar reported and what is the different condition and what is the treatment side. So it depends biochar production conditions depends on the temperature, residence time, condition, and how they give the yield. So there is like slow pyrolysis. When we go for slow pyrolysis, it is like 300 to 500 degrees centigrade, and for minutes to days, and the biochar yield generally comes around 24 to 46%. And this complete decomposition of cellulose and hemicellulose. During the slow pyrolysis process, the biomass completely decomposes in the cellulose and hemicellulose. This work has been published by Lee et al. 2013. There is one fixed bed slow pyrolysis, which is mainly happens in the range of 300 to 700 degrees centigrade in 2 minutes, and the biochar yield around 27%. This causes yield decrease with increase of the temperature. When we increase the temperature, the maximum part, except the carbon is go in the like a gasification part. This work is published by U et al. 16. In our lab, we have worked on the slow pyrolysis. This line like we have worked at the 300 to 600 degrees centigrade for 3 minutes, and the biochar yield was around 40%. We have found a very good yield of the biochar, and we treated the Congo red dye and published in Bioresource Technology Journal, which is a very good and renowned journal in this area. One of our student, Khan et al., produces the using slow pyrolysis, using the rice husk, and they treated the malachite green dye. So this example of the like biochar application for the wastewater treatment. So when I was in University of Hawaii, I have worked on the removal of hydrogen sulfide generated during anaerobic treatment of sulfate-laden wastewater using biochar, evaluation of efficiency and mechanism. So this is like anaerobic digestion unit, and we gave the influent from here, and we produce like synthetic wastewater, and we gave the more sulfate containing water, and here is some anaerobes which work on the removal and utilization of sulfate. We have given sulfate in the form of K2SO4. So what happens when the hydrogen sulfide produces inside this anaerobic system? The production of biogas suddenly decreases, and the pH got increased around. The pH go towards the acidic side. So, but the anaerobes present in this system, they work better on the pH 8 to 8.5, because they are like alkali loving microbes. And so when we use these gases from this place to insert in the this biochar column. Here is the biochar column. So when we insert this gas, the whole gas, biogas containing H2S gas in the biochar column. So because of some polarity and some things, the H2S gas was was fixed in the biochar pores, and the production of biogas was enhances. It started enhances, and the performance of the anaerobic bioreactor was suddenly improved. So so it concludes like the hydrogen sulfide is is an obnoxious and highly corrosive gas, which is generated during the anaerobic of sulfate-laden wastewater, including the animal manures, and such wastage streams are generated by several industries like pulp and paper industry, some tanning, molasses, fermentation. This molasses fermentation, distillery slopes, it comes under the anaerobic process. We have worked on this. So removal of hydrogen sulfide from the biogas was investigated in a biochar column integrated with the bench scale continuous stand tank reactor. This is the like continuous stand tank reactor, and it's the anaerobic biodigester also. So this is connected with this biochar column. So synthetic wastewater containing sulfate concentration around 200 to 2000 milligram sulfate was used as a substrate, and the CSTR was operated at an organic loading rate of 1.5 gram chemical oxygen demand per day per liter per day, and a hydraulic retention time of 20 days. The reactor was running for the like 20 days HRT, and after 20 days, it was observed that the biochar was able to remove about 98% of H2S for the ranges of concentration from 105 to 1020 ppm, especially at high moisture content of 80 to 85%. The very high hydrogen sulfide absorption capacity up to 273.2 milligram hydrogen sulfide per gram of biochar is expected. We have found that the 1 gram of biochar was absorbed 273 milligram the H2S, and this enhances the hydrogen sulfide oxidation into sulfur to sulfur and sulfate. These findings brings potential novel application of the sulfur-rich biochar as a source of sulfur and in essential but often a deficient micronutrient in soil. So what happened when? Hello, ma'am. I'm audible.
Yes, sir.
Okay, so when we treated this hydrogen sulfide, and when it comes in the biochar, so this sulfur is treated as a fourth important nutrient for the crop after nitrogen, phosphorus, and potassium. So we have done some basic experiment in the lab, and we found that we used some leguminous plants to see the effect of this sulfur, and it was found that uh, the sulfur content was better than the normal soil and normal biochar, which strengthen the plant health. After this, this work was done using the biochar for the treatment of phosphate-rich water. Nearby some fertilizer industry, they throw their waste in the some river system, and they create the problem in a river, and it has like more phosphate in the water system. So they made a column, they made big column, and they passed through the column, and this biochar absorbed the phosphate things, and again this biochar used as a phosphate recycling to the soil, and the plant can utilize this phosphate from the biochar, and they grow, and this biochar converted in soil as a fertilizer, and the water is getting clean. So it showed like we have fertilizer input and plant intake from this, and the harvesting of the crops. Again, this showing like how this figure has a mechanism. So some phosphate rich pool, there is a sorption of phosphate, and the sorption desorption some labile phosphate, and the soil microbes act as a some soil microbes convert this phosphate to take the plant, and then again it comes to the side. This is showing like biochars different applications and basic mechanism of uptake of phosphorus nanoparticle by plants and microorganisms role. Yeah, so this is showing like the different kind of adsorption kinetics involved in the when biochar use like some adsorption. So there is some mathematical model like kinetics of isotherm and various kind of dye pollutants and biochar used. So several researchers has worked using the various kind of pollutants like methylene blue, the techniques like adsorption. They have used the removal efficiency. They found the removal efficiency around 71% to 99%, and they used first order and second order. Langmuir and friendly. Langmuir is the adsorption kinetics which show the one layer, and the friendly is showing the multi-layer adsorption capacity. And the use of like cow dung biochar, sludge biochar, rice husk biochar, cow dung biochar, casuarina seed biochar. These work are only our lab work, and not we are showing the data from the any other lab. So we have worked, we have prepared almond cell powder, which is a rich microporous activated carbon, and we treated hexavalent chromium, which is very toxic, and it was found that it is adsorbed around 202 milligram per gram of the almond cell powder of biochar. This work was presented by Rai et al. In 2018. And this wood chips is Sprouse pine biochar was used in the 20% anaerobic biochar system, and it reduced the hydrogen sulfide during the anaerobic treatment. And it was found that it has removed 98% with a QE.31 and Q1.04, and R square value was 0.73. This work was published by Kanjurang et al. This work was in our Hawaii study. Yeah, so recently reported this is reported by the other researchers. They have worked on the various kind of biochar from wood derived biochar, and the pollutant were used perchlorate ions, carbyl atrazine, organic pesticides, bentazone, two neutroactive pesticides from waters, diazonium pesticides. So for the diazonium pesticide, they have used coconut shell modified biochar, and it was able to reduce 98.96 milligram per gram of the diazonium pesticides at pH 3 to 9 in 2 hours. And the absorption concentration was 2 to 10 milligram per liter. This has been done by Behram et al. 2020. So this is showing some like highly efficient bioadsorption of malachite green using Chinese fan palm biochar. So in our IIT BHU campus, there was the plant Chinese fan palm, and we have used its seed as a biomass, and used in the pyrolysis chamber. We prepared the biochar, and we found that the malachite green is an hazardous azodye with cytotoxic and carcinogenic nature. So we prepared the Chinese fan palm seed biochar, which had excellent to the used used for wastewater remediation. A maximum malachite green loading was found. 21.4 milligram per gram was achieved during this study. Langmuir model for this Chinese fan palm seed biochar was found to with a high R square value of 0.975. The bioal had a significant antibacterial capacity against gram positive and gram negative bacteria. So when we produce the biochar, we have some gaseous products and some liquid products. See, this is the like biochar chamber. So when we raise the temperature, so from here it prepared the biogas, and when it condensed, so there is some bio oil, and this bio oil characteristics, it depends on the biomass. What kind of biomass we have used? Suppose we have some medicinally important plant we have taken. So it may contain the some kind of chemical which may help as an antibacterial activity. So we have this Chinese fine palm biochar. When we produce, we found that it has a very good antibacterial effect towards the gram negative and gram positive bacteria. And see, this figure is showing like how it is in adsorption study. See, this is like this dye is containing malachite green dye, which has like a dark green, dark blue color. And here, after like 2 to 3 hours, it suddenly we found that this has like a transparent water on the towards the bottom side, and here is the biochar in the flask level study. So it was very effective for the adsorption, and its bio oil was very good for antibacterial test. And it was found that using it was found that the biochar prepared using fruit the yield is a significant amount of biochar and bio oil. 1.346 kg of fresh and clean fruit was fast pyrolyzed at 500 degrees centigrade in a laboratory scale pyrolyzer, resulting in 0.5 kg of the biochar and 0.8 liter of the bio oil. Chinese palm seed biochar yield came out to be 36.2% and bio oil yield came out to 59.7, accounting for nearly 96% from the input. So this is showing the malachite green removal like 100. It's like showing at pH 7 and temperature 35 degrees centigrade, and when the dye concentration was around 50 to 250 per ppm, it reached around 90% of the adsorption percentage. So the batch studies for the malachite green adsorption using biochar obtained, and it was conducted, and the removal was around 100% within the 24 hours. Results show that a maximum adsorption of 99.7 occurred when 1 gram per liter of Chinese fan palm biochar was used to adsorb 150 ppm of malachite green. So it was found that the biochar was the Chinese fan palm seed biochar was able to maintain its percentage of adsorption and desorption at 42, 100, at 80 to 90 percentage respectively. This slide showing the comparative studies of the various biochar and its adsorption capacity. So with other researchers. So the present study was done Chinese palm fruit biochar and line Moore isotherm model was used. So it was showing like 21.4 milligram per gram at the R square value of 0.95, and but others have reported major because their biomass was various. Like they have some cassava stem biochar, some have eucalyptus wood particle biochar, few have paper sludge and with husk iron modified biochar. Yeah. So when we modified the biochar using any things, so what happened that time? There is a functional group enhances. Suppose the biochar has one functional group where the one pollutant molecule will bound, and when we pre-treat with the other any element which has a more bonding site, so it creates the suppose any element which has like a 4 to 3 binding site. So its one binding sites will bound with the biochar, and it has three bonding sites where the three pollutant will come and fix there. So that's why when we using the pre-treated biochar, the adsorption capacity increases with the normal one biochar. Someone has used the algal bloom residue hydrochar. Like when we go through the riverside also. When we found like there is a green layer in the lake and the thing. So this is generally some algal bloom, and they use this algal bloom as a biochar to study the various kind of treatment system for the dyes and agrochemicals. And some Zhang et al. Has reported like it has a drop-in capacity of 89.1 milligram per gram at the R square value of 0.9. So here our bio oil show the antibacterial activity. Like we have used this bio oil on the Serratia species Pseudomonas fluorescens, Bacillus subtilis, Escherichia coli, and we found that the zone half inhibition developed in various bacterial species after incubation with bio oil, and the antibacterial activity of bio oil in 4 different bacterial species, and it was found that the it was very effective in the to stop the growth of Pseudomonas species at the 200 ppm of bio oil. So we can see here when we increase the concentration of bio oil like 200 ppm, so the growth of microbes are reduced as compared to less concentration. So here we can find the Pseudomonas is around 0.1, this OD 0.1, and the Serratia species has OD around 0.2. And when the concentration was very less, around 25 ppm, the growth was around 0.4 of the Pseudomonas species, and Serratia species had 0.5. So this shows like it has this bio oil has a antibacterial activity too. So now we come on the economic analysis of the for simultaneous study of the industrial application. So generally when we produce the biochar in a pyrolysis unit with a capacity of 4.75 liter in a batch experiment, it used approximately 0.6 kg of the biochar was taken in a single batch with 40% yield and 44 ml of the bio oil. The pyrolysis unit consumed around 4.2 kilowatt power, which is around $0.75 per kg of the power consumed. The raw material was used, obtained generally in free of charge, and was thus not added to the final cost of biochar production, because of it is like a laboratory study, and in our campus it was available free of cost. But when we go for the like pilot scale, it will come here. But generally it is cost effective. However, the transportation, cleaning of the biomass and labor charges may be approximated $0.15 per kg of the biochar produced. Although purchases of the pyrolysis unit is one-time investment. Only this technique has a cost when we invest one-time investment to purchase the pyrolysis unit, which comes around $720. Thus, the total production cost for the biochar may be approximated $0.91 per kg besides 440 ml of the bio oil, which may be used for further application. So this has one another example for the sustainable catalyst of lignocellulosic biomass, composite as a highly efficient biochar, a facile strategy for production of bioproduct and abatement of emerging pollutant. So as we know, generally the biomass having a lignocellulosic compound, a component which acquiring rich sources of pyrogenic carbon and environmental benign naturally produced biochar are implied to explore catalytic efficiency and mechanism application in various routes. Identification of biochar as efficient catalytic substances has involved both investigation to explore its catalytic potential and implementation in diverse routes. So high carbon content, large specific area, and high cation exchange capacity and stability of biochar has raised its utility in environmental remediation. So these are the factors which show how and why the biochar is important for the any kind of environmental remediation and its solution for the pollution. So recently, to increase absorption efficiency of conventional biochar modifications, to create composite biochar has been initiated. As I told earlier, that we can increase the bonding sites using various kind of metals and so modification may alter surface functionality as content, surface charges, and surface area, subsequently enhancing fixation and removal of the toxic compound. Therefore, to proffer detailed mechanism and applications of biochar, it, this study conceptualized the effect of biochar is very important and composites on pollutant eradication. Moreover, various synthesis mechanism, modification process, properties, and consumption of lignocellulosic biochar composites, along with mechanism of the pollutant removal are expounded, and there is a need to study more and more. In summary, the biochar composites have wide applications, prospects in providing sustainable bioeconomy, mechanism, and impact of biochar should be further investigated. So this is showing like when we use the lignocellulosic biomass, it contains generally cellulose, hemicellulose, lignin, and this is like various kind of process parameters at which they prepare. The same thing, it produces around the biochar, syngas, biofuel, and it's functionalized biochar. It has application like nano-based biochar composites, nano-zero valent iron, the clay-based biochar composites, monoportlanite, the metals oxides, magnetic biochar composites like nickel, iron, and cobalt. So they have the advantages of immobilization of pollutants, syngas production, tar reduction, soil amelioration, carbon sequestration, controlled release of the nutrients in soil, catalytic degradation of contaminants, and this is the mechanism of pollutant removal. So any pollutant when come, so they have some electrostatic interaction, pi-pi interaction, ion exchange, and they fix the pollutant on their surface side. So more attention should be given to stability and adverse impact on the environment. So this is the schematic representation of modified biochar synthesis and proposed mechanism for degradation of pollutants by functionalized biochar activated persulfate and hydrogen peroxide. So here, when we modified the biochars, so modified biochars have like porosity and surface area more. It is pH sensitive, surface functional groups, carbon content, mineralogical component, and we use the biochar here. They have given one example how it is iron, iron modified. So they used some K2 FeO4 and they pyrolyzed the system. So the iron was dropped as a porous biochar composite, and here it is showing the absorption of contaminant has increased as per the normal process, and the intermediate products. So modified biochar for catalytic degradation of pollutant here, and the biofuel and bioproduct production using modified biochar as a catalyst they use. And here this biochar as a biofertilizer and enhances the like sulfur content in the soil, and it's showing like when you use the acidic modification, alkalic modification, oxidation, metal oxide modification, and it goes to the soil and soil microorganism and plus enzyme, so it enhances the nutrient retentions like nitrogen, phosphorus, potassium, and sulfur. Nitrogen drift, it creates carbon drift, enhanced gas water flow, increased water holding capacity. Suppose this when we go towards the some sandy soil like in Rajasthan area, so we can found when we mix the soil, the biochar in the sand, it will hold some water and it release slowly as compared to not holding in the sand. I also found that they used agricultural techniques with the help of Israel technology. In Rajasthan region, they made some uh, they modified their field as a gap, and they fixed polythene inside the filled as a tank, and they filled sandy soil on the top, and they grown the watermelon in this area. So because of the water holding capacity in hands, using the this plastic and this modified technique, they supply and they produce the huge amount of watermelon. So this kind of techniques are used in Israel also. I have some collaboration in Hebrew University, and they are working on this side. Also, this biochar can use as a composting. Like presently, I working here using the this some lignocellulosic waste, and using the mushroom cultivation. So after generally mushroom produces after 20 days, 35 days, and the lignocellulosic biomass was left over, and we are using this lignocellulosic biomass which is left over after the mushroom cultivation as a biofertilizer. So this is like this comes towards the composting side. So here we come on the conclusion that the major pyrolytic product of the like biochar is highly employed in bioproduct synthesis and contaminant removal. Moreover, the proper management of agricultural waste is the main concern that has been subsequently addressed by biochar production. Although the extensive and optimum utilization of biochar in various applications requires further modifications that cause the synthesis of modified biochar. Effectivity of the modified biochar is highly influenced by synthesis process, pyrolysis temperature, and method employed for surface modification. There are major two modifications methods that have contributed to the successful doping with metals, clay nanoparticles, and other hetero atoms, and subsequent activation of biochar surface, which is highly enhances the electrochemical activity and adsorption potential. Modified biochar exhibits high adsorption capacity to remove heavy metals, ions, pharmaceuticals, and personal care products, pesticides, herbicides, and organic dyes from the water and soil. Furthermore, the functionalized biochar also showed impressive performance as electrodes in bioelectrochemical systems, providing high capacitance, power, and energy density. However, to attain environment-friendly and economical implementation of modified biochar, in situ synthesis, strategic activation, and removal should be synergistically optimized. So we have published the papers on the biochar, and this is my overall research output. Thank you for listening. And ma'am, I want to share one thing. Like I'm working here in IIT Guwahati, and we have developed one another techniques. So now we are working on the sustainable polymers, and this is the emerging area, and this center has been established new. So I request to you can also send some students who can get admission for their masters and for their PhD study here, and we work generally we promote the sustainable polymer study, like some biodegradable polymer. So he's head of the center, Professor Bimal Katiyar, who is a very well-known name for the biodegradable polymers and biodegradable plastics. So there is here is the link to go, and students can join here. It's a new area, and student can get admission here for the things. So okay, ma'am. Now I'm concluding my talk. Thank you, ma'am. Hello.
Sorry, sir, there was some connectivity issue.
Yes, ma'am. So, ma'am, so I like told this is our Bimal Katiyar Search Center, which is it's newly opened in the IIT Guwahati, and students, interested students can join our group as a master's
So,
and as a
so this is
PhD.
for post graduation or graduation?
No, ma'am. This is for the like post graduation, and this will be for like my in research program, not like this. So, and because of the new, there is some chances to get in. Otherwise, after few years, it is very difficult to get admission here because of the huge competitive. And here is a program in the masters in research and PhD, and this is like highly expert professors like. So I
There is
just
some
finished.
connectivity. Yes, sir, there's some
Yes,
connectivity
ma'am.
issue from my side today.
Yes,
Thank you
ma'am.
so
So,
much, sir.
ma'am, we can talk later detail.
Okay, sir, surely, sir. So, if the participants would like to have any questions with sir or any doubts to be answered, please you can unmute yourself or you can even type in the chat box.
Yeah, even they can ask in by email also if they have not.
Yes,
If the
you can
question does
even
not comes
ask
in the
in
clear.
the email. If it doesn't appear in your mind immediately, then you can even contact sir on his email and you can get it from me if you want to get in touch with him.
Yes, yes, ma'am.
Sir, I have one question.
Yes, ma'am.
So far, batch studies have been performed regarding biochar. So, can biochar be used on treating water on location for huge volumes?
Yes, ma'am. So, ma'am, when the suppose, ma'am, we have like one industry for some pulp and paper industry. So this industry has one outlet. So there should be some law. So this industry can use the biochar big biochar tanks, and they can uh, pass through their wastewater towards the biochar column. Like as per the like government norms, they cannot throw directly. So many industry using some membrane treatment, some RO techniques. So they can use the same as using biochar column. So this will reduce. If we want to treat some river, it is not possible, but we can, ma'am, treat like small units.
And sir, for how long can this biochar be used? Like at what time it will get exhausted?
Yeah. So suppose, ma'am, because of the biochar surface area, it is shown that like 1 gram of the biochar has the surface area of the 1 football ground. The scientists say that this 1 gram of the biochar has surface area around football ground. So it has a very huge mm, absorption capacity, and we can recharge also, ma'am. Suppose the any like 1 gram of the biochar treated around 200 milligram of the any pollutant. So after some time when you found it is like exhausted, so we can pre-treat like some alkali treatment, some acidic pre-treatment we can do, and we can recharge this biochar to reuse.
So it can be reused any number of times, sir.
Yeah, yes, ma'am. Yes, ma'am. We have done in our lab. It is reusable up to the six times. 6 times we have used and the reusability of the biochar reduces after the 6-7 times.
So that was a wonderful topic of discussion, sir.
Yes.
Very new area of research which Balendu sir is involved in. And if anybody would like to go for this particular area, I would suggest you please have a feedback from Balendu sir's side. He's always willing to help you out. I thank you, sir, for on behalf of the Civil Engineering Department of IPS Academy, Institute of Engineering and Sciences, Indore, for being here and enlightening us over such a wonderful topic of biochar for treatment of specifically wastewater. Thank you so much, sir.
Okay. Thank you, ma'am.
So we may start, sir.
Definitely.
Very good afternoon to all the participants of AICT sponsored 1 week online short-term training program on water quality complication, restoration and environmental conservation of existing water bodies, Module 2. We have with us Mr. Suresh Kuttiappan, sir. I thank you, sir, on behalf of IPS Academy Civil Engineering Department for accepting our request and being present through your busy schedule and enlightening us over the water quality issues. He is an experienced and enriched engineer at the Kerala Water Authority, Kottayam, Kerala. He is also studied at the Mahatma Gandhi University, at SGSITS Indore, at the MA College of Engineering, Kuthamangalam, Indira Gandhi National Open University, Kochi, and he was very humble and modest that he accepted our invitation for being present here, all in spite of having a very busy schedule. Thank you so much, sir. And I request you to please start with the session, sir.
Good evening. Good evening.
Yes, sir, you are audible, sir.
Ma'am, I have doubt that the slides will be shared from your end or our side.
So as you say, if you say, I'll share it.
Okay.
So should I share, sir?
You should share, please.
Okay, sir. Sir, is the slide visible, sir?
Yeah, that's enough. So, good evening once again, and hope you all enjoying the section, the morning and the evening section also. And I think they have a wonderful discussion regarding water bodies, restoration, water conservation, water pollution control measures, etc., in the previous. And today we would like to discuss with you how we can restore water bodies in a Kerala model way. Here we give more importance to the public participation. So directly going to the topic, I will like to thank you, the organizers and my dear friend Vijay, who had given me an opportunity to address this grateful personalities. And we all know that the value of water will comes to us when we face a scarcity of water. So Thomas More said, "We will never know the worth of water till the well is dry, is till the well of our is dry." Here we have to take our in a perspective manner that the globe is our well. We all working hard to enrich and regenerate the water sources in our earth. We all know that we have a limited quantity of water and pure water is available for us. It is not equally distributed everywhere. So how to regenerate and recirculate to meet our demand of water is our mindset. We all know. Thank you. About 2.8 billions of, that means 40% of world's population experience some form of water scarcity. Access to drinking water is a continuing serious global water issue. Somebody said, if there is a third world war, it should be for the water. That is the crisis. We should visualize it. And we all know that last in South Africa, they felt severe scarcity of water and people died and they fight each other for water. So before such situations comes to our India, we are only growing country. So we should have such discussions and we should have some proper planning to restore our water. The root cause of water quality is a low and decreased water availability is just due to human activity, rather the degraded ecosystem caused by the human activity. As we know that how we drain a water body, all of you know that water bodies are maybe streams, springs, rain, or lakes, anything like that. That will accumulated some quantity of water or that will contain some quantity of water either in surface or in ground. In India, we have 7,90,908 water bodies. It may be lakes, it may be rivers, it may be ponds, it may be small wells, etc. etc. And we should have treat our community as a common resource in the early century. But now it has changed. People doesn't give much importance for these water bodies. So we start polluting these water bodies. Thus the water bodies start contaminating, degrade. So we have regenerate. The early stages, it has everybody has taken the responsibility to conserve the water without any contact or rules. There at that time there was no much rules as we now. But people had cared, they nurture, they protect, they conserve and manage by the law. Even we educated lot, we facing now also to conserve our water bodies. The main aim of preserving water bodies is for the human and livestock population. How this will be degraded? You have to when the public water supply and groundwater development was spread in the country, people start stopped caring, nurturing, conserving water bodies. The urban industrial infrastructure development has changed its water bodies from community resources to a mere dump. So we thought that without these sources, we can live. We will get water through our pipelines. We will get, if you dig a borewell or you will dig a pond, you will get water. So people have thought that if they have the money, they can afford water. But it is not like that. Even though we have money, it's a natural source, natural resource. So we cannot do anything on that. Once it is deteriorated, we cannot restore it until we have spent lot of money. This is a situation. And so that urban, due to the urban development in the country, the demand of water was increased vastly. It is for their daily needs. It is for their commercial purposes. It is for their industrial purposes. We have lot of demand. So what we did was we exploited the natural resource of water available in the country, either in top water and in the surface water. Exploited, overexploited. Rather, I can say overexploited, and we had no of that water. Thus, our rivers, our wells, our storage, groundwater reservoirs, everything started. Once again, the public water supply and groundwater extraction has the main role in deteriorating the river source. Obviously, river sources are deteriorated due to industrial growth, industrial wastage, human activities, effluent treatment. Effluents we are discharging into the rivers, and moreover, the Indian culture, religious activities in the rivers also causing pollution of rivers. So we have to plan and restore our community resources. This government has realized it had taken a lot of time to realize these governments to understand the importance of restoring water bodies. That is the topic we are discussing today. And we'll go ahead with some case studies and analysis. For preserving water bodies, what we have to do is we have to educate, communicate, and build the capacity of communities to manage water available in the local bodies in a better way. Next, let us think about Kerala in a perspective. See, once you look at the side, you understand that Kerala has much problems of water. But even we have enough water, we are facing water scarcity all over the state, especially in the months, especially in the summer season. Maybe it is maybe due to the topographical condition of Kerala, and it is not a. It has three parts, and coastal area is a major concern. We have Western Ghats also. In between, we have midland also. But the width of this state is very less. Start from 20 kilometer width to 70 80 kilometer width. Once the rain falls from the Western Ghats, it will suddenly reach the sea. That is the problem we are facing. Even though we are getting 3000 mm of rainwater in the rainy season, we are not able to restore that water in our state. Water may be the rain, it will within 48 hours, it will reach sea. That is the main problem that we have to. Now, as we all know that we have 44 rivers, but in the 44 rivers, only 4 rivers are median rivers. They have the capacity to store of water. In that rivers, the Peria and Chalakudi Bharatapuzha and Pampa. These are the Indian rivers. And Bharatapuzha and Periyar, Pamba are our holy rivers also. So many religious activities are happening. So hence the deterioration also started. And even if we calculate the whole quantity of water in these rivers, it will be only one third of our Narmada river. That is the thing. But we will manage with the small water bodies. Let's look at it. We have 53 check dams, 236 streams, that is also 600, and 50 lakhs wells. These are the and 50,445 ponds, 1,000 Suryagangal, that is a colony used for the horizontal uh, tunnel discovered in the north part of Kerala, that is Kasaragod. We have a horizontal tunnel. From that, we will collect water and 9 fresh water lakes. So, this is a water body structures, water bodies available here. Let us see how much water is getting. We have 78.04 1 million cubic meters of water in Kerala. But the problem I have said was we don't have the major, we have only medium. And all of you know that medium and major. The catchment area is in between 20,000 and 20 kilometers. We classify these are medium rivers. If it is more than that, we classify it as major rivers. And Kerala, fortunately, don't have any major rivers. And the runoff water is the main problem. As I explained earlier, water will reach immediately to the sea is the main problem we are facing. The compared that I explained earlier, the compared discharge of these 4 rivers is just already explained. I am not going to that. I just say that so less than variance less than the Krishna river, Godavari, Narmada, etc. Restoration of water bodies. We have the Central Pollution Control Board gateway. So when you look at the guidelines issued by the Central Pollution Control Board, we know that how seriously the government viewing that subject. What are the aims they put forward? Let us see that the main objective. Look into the main objective to free water bodies from pollution, and we have to ensure desired water quality criteria for all the people. So for that, we have to keep our rivers pollution free. We have to control the deterioration activities happening near the river banks or near river banks. Preserve excess water during monsoon. We have to go for some techniques to reserve water we are getting during the monsoon. For that, you have to go for some check dams, rainwater harvesting, and obviously Kerala in areas gone for rainwater harvesting, and also in the lower areas we have constructed rainwater harvesting. We are doing it very strictly. And Kerala, a rule was passed. If you are going for multi-story building construction, it is compulsory that we have to plan a rainwater harvesting. And once you submit the plan, then only your construction activities will be permitted by the local government bodies. And restore argument the storage capacities of water. How to restore and augment the storage capacity. Let us see that is an interesting term. storage capacity augmentation. How we can augment this storage? You know that when you construct a check dam, this not only storing water in the river only. It is also enriching the waters in the nearby wells and ponds and other water sources. So we have to like that, we have to plan. And to serve and enhance groundwater feature. Obviously, when we do some restoration, it will definitely recharge our groundwater potential. Increase availability of water for different intended purposes. That is how it. Anyway, we during the dams, we have different oceans for irrigation, power generation, and obviously water supply. Like that, we have to plan. When we planning for restoration, we have to think these phases. First, we have to recognize the phase. We will discuss for each phases in detail. Recognition phase, planning and DPR preparation phase, restoration phase, gap analysis phase, then improvement phase, and fifth comes tendering and implementation phase, and the last monitoring and evaluation phase. We'll go one by one. Recognition phase. Clearly, you will understand what from the word meaning, we'll get it. But it's a how uh, arrive a project and how we recognize the importance of that river protection or restore. We will analyze. For that, we have to collect so many information. It may be related to historical existence. It may be related to the future developments of that river. That may happen in the downstream of the river. We have to collect some geographical details of the water bodies. So how many water is available in summer season? How many water will be available in monsoon season? And what are the potential of that water body? How that river will preserve the water? How many time it will take to flow this water from the origin to the sea? And the collection of hydrological details of the water body, catchment description of the water body. All these terms are known to everybody. Catchment area, meaning how to think about the catchment area. Some of the catchment areas may be dried due to the human activities. In the case study, we will explain more details of that. And next is digital mapping of all the collected information. We have to collect the information and we have to compile the data we collected, and for the storage and use advanced technology we have to use digital mapping. Then only we can manage the situation. That all these phases are managed in the recognition. Next, we have the restoration phase. Once you identify or recognize one source or one water, then we have to think about how we will plan the restoration. This is the most important phase of the water body restoration. Because in this, if there is any mistake in this planning, it will definitely affect the entire project. So we have to, based on the data, river flow, and other information we are gathered, we have to choose a proper technique to preserve, store the water. For that, we have some criteria. Maybe we have to think about the situation in the. We all know that every river has a self-purification capacity. The river itself can degrade the biodegradable matters falling into that. When it is processed, self-purification capacity of the river starts deterioration. So we have to find out the sources of pollution that may be known sources, known pollutants, and point pollutants. So we have to find all these things and quantify them. Which are the industries polluting? What are the pollutants they are left in the river? Which are the effect of the pollutants to the water bodies? All these chemical parameters should be studied, and we have to plan and treat the water according to that. And we have to use some technique to remove such chemical from the water. So that assessing detailed gap analysis. It may be sewage management, it may be it may be waste management, or rather the education for the public or local living near that, and identification of associated issue. This identification of associated issue is totally human activities. We are giving less importance to preserve our water bodies. So it should be detailed. It should be thorough, studied thoroughly. Planning DPR preparation phase. We all know for every project it should have a detailed. In the detailed project should be we have a scope of work, we have a planning schedule, we have a monitoring schedule, and we have an maintenance schedule. So the DPR itself, we are planning the stage-based implementation of the project. So for that, if you are planning for waste management, we have to think about that. And if you are going for desiltation and the DP, these two terms are very important, especially when we consider the case of rivers. As all know that many rivers are dead due to accumulation of the mud in the mud and sand in the river bank. It will cause some island in the river. It will distract the flow. And obviously the construction of bridges across the river also causing a main reason for the accumulation of sands in the bridges banks. And this will definitely cause the growth of plants, maybe aquatic plants, or rather land plants, maybe crops. So we have to identify and we have to use the technique to deteriorate these plants for rootage. Sometimes we have to use for that mechanical and biological control measures. Everybody knows that mechanical control measures are very easy. We can use the machines for sometimes desilting. We can go for dredging, and sometimes we can specially design a pontoon erected water mechanism for removing these plants from the water. And environmental friendly techniques like biological matters we can use for that. So these biological matters definitely remove this. They will eat some bacteria and other insects. They can eat these plants and they can control the growth in these rivers. Next thing we have to think about that. What are the things we are discharging into the water bodies? And the action against the violence. This is the main concern. And many local self-government institutions fail to do these items. They are lacking courage to enforce them. From the beginning onwards, we have these laws existing in our country. In 1994 onwards, water prevention and pollution control rules are existing. 1986, the environmental protection and rules existed, and 1991 it was modified again. We have so many rules of Central Pollution Control Boards, Environmental Protection Agencies, and Ministry of Environment and Forest. But the fine they are charging for the violators are very less. That causes the people to repeat their activity because they have the interest. They think that if the fines are very less, they can pay the fine and they can do the activity. If they go for an effluent treatment in the industry and the fines are very less. So for that effluent treatment, they have to invest lakh of rupees. But for the violation and the payment, uh, fine payment, they have only less rupees. They have to pay. This is the situation. Then removal of enforcement and blockages. As I said earlier, while we constructing the river bridges, due to the engineering uh, application, we are not bothered about the environmental impact of it. For major bridges, we have environmental studies After that, only we will get permission. Even though we are not bothered about the blockage that goes in the river. We are not ensuring the free flow of the river. So if you ensure the free flow and if you plant the bridges according to that, the blockages will be reduced. These diesel will be reduced, EV will be reduced. Everything can be. Another thing is protection of drainage base. Many municipalities and Nagari, especially, they are not having proper sewage treatment plants in the country. They are disposing all the sewage directly into the river, especially to the corporation boundary, their own boundaries, because they think that once it is over from their boundary, it will not affect their health. But they forget to remember that another fellow upstream of the river also thinking the same thing. He also discharging the effluents and the sewage to the river. So definitely each person has to control their such activities. They have to go for the sewage treatment line and they have to dispose the materials into the water bodies into that way. So every corporation, town, every municipalities, everybody should go for sewage treatment and they have to dispose the treated water only to the bodies. And for that, we have to stick on the rules and regulations. And last, the flood control measures. If you are not allowing the river to flow in a free flow manner, it will definitely spread over the land. That may cause the flood. And Kerala faced last 2 3 years severe floods. And maybe everybody read about that recent flood happens in Chennai, Bangalore, and other developed cities. It is because of that we destroyed the free flow. And all this thing, everybody knows that depending upon the quality of water existing in the water body, we classify this into 5 categories. And all of you know that when the glass of water comes in A, without treatment, we can use that water. But nowadays, can anybody say that such water is available in our India? Maybe in Himalaya we can get some sources. I think so. After that, we cannot find such A categories of water. And for that, the conditions or criteria are mentioned in the third column, the table, and everybody must know all these things. I'm not explaining in that in detail of that. Outdoor bathing, we have to go for B category. Drinking water source after conventional treatment and disinfection. The categories start here again. C, D, E are our major categories. These categories has to be converted into B. These C categories should be converted into B with our restoration. Then we will doing some restoration. This is the concept we have to understand. Calculating the value of the river potential. We have such criteria issued by the CPCB, and according to that, we'll calculate one value that depending upon the total score mentioned in the third column, total score, we will identify whether it is belong to critically polluted, whether it is belong to severely polluted, whether it is belong to moderately polluted or less polluted. So we have to make every water bodies to the category 4 and 5. So what we have to do is we have to reduce two components. One is the fecal coliforms discharge and other is POD value. For that, even though we will think heard, first we will come to the mind was it can be easily done. Reducing the fecal coliforms and enriching a BOD value is not an easy task. It needs so much patience, so much planning, and well monitoring is necessary. Next. And next phase is improvement phase. We know that whatever maybe we plan in the DPR preparation phases, it may have some changes. So what are the changes we have to incorporate? Should be based on the discussions, based on the suggestions, maybe from the local people itself or other experts. We have to think about that and we have to incorporate it in our project phase itself. That will help. Maybe we have to go for drainage waste management. Sometimes we have to identify some of the green and buffer zones. We have to separate it. Otherwise, it will again cause severe damage to that area. Then creation of biodiversity and we have to think about this. This is the best economical and eco-friendly manner of restoration. So we have to think about this and monitoring implementation of action. Once you plan the action, doesn't mean it will work. So we have to monitor closely and we have to implement in a successful manner. So we have to do each and every step in these restoration projects very closely and very sincerely. Then only we will get the result. Otherwise, we won't get the result. The money we are spending uh, will be wasted. This is the big problem. And last, tendering and implementation phase. We think that it will be quoted by some contract persons. They will take. They may be experienced in that. It depends upon their strength. We can do anything. It's not like that. We have to plan it. We have to choose the right person with the right technique. Then we have to award the work to that person. Next. And next phase is monitoring and evaluation. When you plan a project, we know that we definitely incorporate some softwares and some techniques for evaluation and monitoring. But sometimes it will not work. It will be become only theory. For that, what we need is the participation from the local bodies is very much necessary. So we have to create awareness on the public. What is this project? Why it is for? It is for their health. It is there for their kids and for the next generation. And how to educate them. Continuous teaching was very necessary and severe discussion was needed. Then only they will understand. They don't like to use their habit. They have habit of throwing anything into the water body. Especially in Kerala, we are facing that problem because we have so many backwaters. People have the habit of throwing everything left in the home to the water body. It will catch the lake and seas. So they are bothered about throwing treating the wastage in their home. Now it was started. In Alappuzha, our Honorable Minister Thomas Isaac had initiated. Now it was reduced and we are preserving the Empanelled Lake from the all know that the Empanelled Lake is the biggest lake in Kerala and longest lake in India. And to the tourism activities, it started deteriorated. Now it was also controlled. Every boat serving into the lake get a certification from the pollution control board. Then only they allow to use that boat lake. So we strictly monitoring and control the number of boats discharging traveling to the lake also. And we are go on for CTPT unit for the disposal of waste from the houseboats, etc. Again, promoting public participation. dissemination of information, creation. So once you convert or reserve one water storage body to keep it aesthetic, we have to do some recreation centers, recreational activities to the river. Then only public will have a. This is a simple implementation arrangements that we discussed. Several bodies to manage and they have to supervise the activities, and all of that it was guidelined by the Ministry of Environment and Forest for the implementation of restoration of water bodies in a unique and uniform manner. So you see that it has responsibility for everybody, not only for the government, not only for the LGDs, but for water users association. That is the common public. Everybody has to sit together. They have to plan, and it has to be approved from the district level and state level has to be viewed, then approved by the Ministry of. So in these steps, we can reduce the malpractice and mismatches occurred in the planning, implementation, and preparation of EPR. Before going to the case studies of Kerala, let us understand river restoration. What is the need for river restoration? River restoration we are doing for preserving water for the entire community. This may be utilized for the cultivation. This can be utilized for drinking purposes. This can be used for irrigation. This can be used for recharge the groundwater. All of you know that a river is a source of water that originates from mountain and flows downwards until it reaches. Rivers have the potential of carries water, nutrients to the area. So restoring and ensuring free flow of rivers need severe attention. Otherwise, it can cause the damages of water body and water scarcity in the towns. Restoration rivers can be 4 points. It have a catchment area, channel character, and river flow, river water. These are the four important factors we should think about when we planning restoration of rivers. For that, we have to approach an ecosystem way. Ecosystem approaches mean that there is an energy flow within the system and an organic linkage exists among the various components system and its affects both on the side and outside. Here I am the case study. It is from Kottayam district of Kerala, the middle of Kerala. We have a river. So main river is Pinachinar. Its tributaries are Bindakaya and Kutira. It was almost dead. Water, no water. In the earlier times, people used these water bodies for traveling from one place to another. This is free for water bodies. Later, due to the human activities, it dead, unmining, and other encroachment destroyed the India. So people near or downstream of that, especially Ayman and Maragam, those villages, Tirwar, in these villages severely affected. So people start thinking about how to regenerate the river. So they worked on that. One person who is working as an advocate in Kotte, he started to think about advocate Kumar. He taken it seriously. He taken his, he conducted a lot of meetings. They conducted people, gathered the peoples of the river banks, studied it, and they, as I said earlier, we started from the collection of data. Next, from collecting data for that, what we done is we walked along the river bank. We studied it. The group of people gone along the river bank. They noted the problems. They identify the blockage. They identify wherever we have to go for desilting, wherever we have to go for planting, which are the tributaries are dead, and what to do to regenerate that tributary, how these flows are affecting our road. And by the studies of people of the locations and nearly 15 panchayat members, college students, and other environmentalists, obviously politicians, political leaders, also taken part in the work. They studied, they what are they finding, they collected data, discussed, they analyzed, they think about the problem, how to remove all these problems. So in Kerala, as you all know that we people have interest in fishing. And in the rivers, we have the local techniques. We will construct some small boxes. We will allow the fish to go in that for a particular period. When it become higher size, we will take it and we will sell it. So these such boxes are disturbing the free flow. The figure itself, you can see that will the plant growth and the islands in the river. This one in the figure you can see that one is constructed in a economical way, but not in an environmental way. This has caused a island formation in the heart of the river. This is what we studied. It. We again sit together and we find out that around 200 kilometers of small rivulets and streams which supply water to the rivers have been revived to strengthen. It is not an easy task. People have different cultures. They are not bothered about the downstream people. So they thought that why I have to spoil my land. They are using that land. If you give again recharge the rivers, I have to protect these river banks. So why should I have to pay a lot of money again? So again, from group level discussions, and we say that this meeting in a colloquial way that Kudumba Kutayama. So that is a grouping of family members. In the family members, only 10 maybe 10 to 20 members are participating. 10 to 20 families are sit together. We educated them and ensured them they are getting benefit of that is one. They are not losing anything. They will get benefit and their next generation also will get benefit. Later, after severe discussions, it is happened and people will put together. We now regenerate 130 kilometers. You don't believe that 130 kilometers without any contribution from the government. All the contribution expenses for this, I will say nearly 200 crores of investment had done by the public itself for regenerate 130 kilometers. This is the strength of public participation. This is the idea I would like to share with you because the public has once they realize the problem, then the money spent by the government will be same. This is an example. Now they are enjoying the facility. Water tourism was improved. Several tourism locations was identified. Government planned according to that. Government is given money for such development activities. They doesn't want any money for this restoration or other activities of the public. Public has find for money for, but retain that restoration. Several other activities are necessary. So government for the fisheries, government put money for the agriculture, they put money for the Harida Kerala mission. This is a typical project implemented by the Kerala government. And from these activities also, we regenerate. You see that how people are working and how these machines are working. They don't bother about their health and others. They know that nothing will happen. If they doesn't work, they have to spend a lot of money. So instead of that, they actively participated and our cost is reduced. Next. See some salient features of network. I'm not going to details of that. There may be some issues. I will explain that two issues. Last 2 points. Illegal fishing that we will discuss earlier. Illegal fishing and destroying marine. You think that what will happen when people are doing fishing activities? What will happen when they go for this box type fishing? They are doing some severe damage to the aquatic life of the. We know that the fish enrichment will happen only the traveling from exterior will that fresh water and saline water interpretation is very necessary. So for the enrichment of fishing. So if you go for this box type culture, next generation will happen. So we removed all these things and we banned every illegal fishing at the rivers. Next. These are some features. And you see that after this regeneration, nearly 5,000 acres of land start cultivation. These cultivations were not happened due to the scarcity of water. After regeneration of this, nearly 5,000 acres of land can be farmed. We are doing party farming in 5,000 acres after this regeneration. This is the different steps. Our honorable Minister for Agriculture is having traditional cap on his head and lighting the lamp. And this paddy cultivation step we are seeding and other activities are seeing the pictures. Next. And see the difference. How beautiful it becomes after regeneration. You see that. The naturality of Kerala we brought back. This is the main advantage happened. We are generally tourism centered state. So this scenery will brought back the tourism enrichment in Kerala. Next. See next under river. This is also a branch of Holy Pampa. Maybe all of you heard about Pampa. It's related to Lord Ayyappa. So one major tributary of the long Pampa was known as Varataya. Actually, it's a term given by from our language Malayalam. That means a dead river. Varata means dried. So nothing is there, no water. Hence, this river becomes this tributary name becomes Varata. Now we regenerate. This is the first stage of process. Later that, due to public participation, we regenerate. As in the first case also, here our Honorable Minister for Finance had taken initiation. He walked along the river bank along with the Minister of Water Resources, uh, Madhuti Thomas. They took the lead role. They convinced the people, and the people will be actively participated and see the different activities happening. The next slide. See, for all these activities also, they hardly use any money from the government. For this Paratayar also, nearly 28 lakhs rupees were collected from the public. They have contributed other activities. The 28 lakhs is for the missionary. They have the collected money and their contribution, their hard working their ability not accounted in. They formed different WhatsApp group and see the long conducted along the river and lead by our minister is a stick and men with a green cap and the nearly 500% are our ministers for water resources and finance. And they lead the role. And another lady, first figure, was our last health minister, now present health minister. They all lead, they all come to the field, educated the people. They convinced that without this, our existence will be possible. Like that 9 kilometers will be regenerated. Next.